And
In
you
the
don't just
UK?
look at no, and you don't
Yes.
just look at the UK. You look at the
No,
whole thing.
all I'm dealing with is the UK because
Well,
I
then
can
you're
definitely say
tiny-minded.
they are all grid reference and they do fit together. Yes.
Wow, Bev, you're scared tonight. Sorry, dude. I don't know what happened.
I'm not scared, dude. This
Okay.
is a pretty weak attempt by you because you've just deflected from Dross, who was talking about the grid reference system in the UK. He even give us
You're
a
right.
picture of
I
it.
did. I'm sorry. Go ahead, Dross. Take back.
It's all good. It's all good. We're all sharing the mic. It's all nice and calm. So again, just to go back to my point, because I agree. So that's the method that we use for taking from the grid system back to GNSS, longitudinal latitudinal coordinates. So the fact that we can transition from A to B and they have meaning means what?
That it's not spherical geometry.
It means that the two systems are compatible with each other in the scale that we're looking at.
They're both two-dimensional coordinate systems.
All surfaces are two-dimensional.
No, that's not true.
Show me a surface that has depth.
A sphere.
A sphere is a three-dimensional object. Please show me a surface that has depth.
The surface of a sphere.
Surface of a sphere is two-dimensional. Surfaces have no depth because it's a two-dimensional object.
Wow, this sounds
Please
like
show me a
you've
surface
got a
that
bit of
has
a mantra
depth.
I
going
said
there.
it was a three-dimensional. You just said it was three-dimensional, then you switched to two-dimensional.
No,
What the
a
fuck?
globe is a three-dimensional object. A surface, by definition, is two-dimensional. Doesn't need to be flat to be two-dimensional. It just needs to be the surface that we are addressing.
Why do you want to talk about turning the surface into what you're trying to turn it into, and not what the sphere is?
Because we're discussing the surface, not the underneathy bits. I don't see why everyone's hung up on this. I mean,
We're not
someone was trying to
hung
make
up on it.
someone
We
was trying
live
to
in
make the
reality,
argument that a
Dross.
three-dimensional object, like a piece of wood, just because you don't have to alter your z-axis at all, is therefore two-dimensional. That surface.
That's what 2D
And I said,
is.
yeah, I agree, because all surfaces, by definition, are two-dimensional.
Length and breadth.
Yeah, there's no depth to a surface.
Well,
As soon as you
a
have depth,
circle.
you're no longer talking about a surface.
Circle
You're
is
talking
a
about a three-dimensional object.
two-dimensional shape. A circle. A square is a two-dimensional shape.
And I can take that two-dimensional
and
shape and I can
a
deform
sphere
it.
is a sphere. What's that?
That's a three-dimensional shape, but the surface is still two-dimensional.
But the surface is all you look at. It's all you see of
And it's
the
what
sphere.
makes the sphere. It's what makes up the sphere, is the surface of it. The sphere isn't the nothing that's inside or the nothing that's outside. It is the surface of itself.
That was nice.
Very true.
Yeah, nice.
Right the hand. Very true. Right, Druss? We'd have to agree with him, wouldn't we? Surely.
Yeah, all surfaces are two-dimensional. I agree with you.
We get two-dimensional t-shirts.
For $1.05.
We do a t-shirt design. We get DP to do that. This t-shirt is 2D.
But moving on the surface of the ocean, I'm kind of really just dealing with the surface when I'm examining it. If I'm talking about the depth of the ocean, now I'm dealing with, the ocean as a three-dimensional object. If I'm dealing with a point on the ocean.
Can I ask you do you think flat is an orientation?
Well, your sexual choices are up to you.
Okay. Do you think flat is an orientation?
An orientation? No, not particularly, because I could have a flat wall, I could have a flat floor, or I could.
It would be
have
a
flat
surface,
ceiling.
A visual surface signifier, then, right? Flat.
Well, you could define flat as a surface, but I could take a piece of wood, a three-dimensional object, and I can say, this is flat. So it depends on it. I was using the geometric definition of a surface, which we should all agree a surface of anything is two-dimensional, because we're not discussing the depth of it, we're only discussing the breadth and the length of it.
Okay, so you would call the surface of a flat two-dimensional then?
Yeah, I'd call the surface of anything
Like
two-dimensional.
a square two-dimensional?
I'd call the surface of a cube two-dimensional.
Yeah, because it's squares.
I'd call
Obviously.
the, I'd
Six of
call
them.
an
Would you
oblate
call the
spheroid
surface
surface
of a
two-dimensional.
mountain two-dimensional? Really?
Whether the shape's regular or irregular, if we're discussing the surface, we're only discussing 2 dimensions of the object.
Okay. Right,
Yeah,
that's
he's a
bit strange,
two-dimensional earther. He
That's
thinks
strange.
he lives on a 2D.
No, because I deal with height as well.
Everything's 2D though, right? You said
No.
everything's 2D.
No, the surface of anything is two-dimensional, but
Yeah,
in the world I operate in, I also deal with height as well, because otherwise I bump my head on the shape.
So that's the third dimension, right?
But I can't really,
What if
bump
that
my head
surface goes
if I'm
across
just dealing
all
with the
3
surface, 'cause I'm not-
dimensions?
It's a deviance. It's a plane, isn't it? And then you've got deviance from the plane.
No, the surface is just the surface. The surface can be a regular shape, an irregular shape, whatever. All objects have a surface, and when we're dealing with the definition of a
Yeah, but
surface,
when
it
you're
is by definition 2 dimensions.
But when you're talking about something like, the soil in which we stand on, I mean, isn't that more than just?
Yeah, because when I
Two
stand on soil, I'm not dealing with the surface. I'm dealing with the actual texture of the material I'm on, and generally, I'm going to make an impression on soil unless it's really hard packed.
What if you picked the dirt up and made it into a ball?
It'd still have a surface.
How do you have a 3D object without the 3D surface to comprise it?
Because then we're not talking about the surface, we're talking about a 3-dimensional object. We're now talking about the depth or the height or whatever. We're now operating in another dimension. But when we're talking about surfaces by definition are 2-dimensional.
But a surface of a
Not
3D object
true.
the surface of a 3D object follows the contours and dimensions of that 3D object, therefore making the surface just like that 3D object, 3 dimensions.
That which bounds the 3-dimensional object is a surface by definition. Definition 2, book 11, I think.
Just makes me wonder if anybody's ever taken like the square footage of a room.
Exactly. That's a good one. I like that.
I'm just saying, like you want to say the surface is 2D. It's like everything we have in reality is 3D. And the only way you could ever reference 2D is like if you take a measurement. That measurement in and of itself, length and breadth, is just a 2D measurement.
Yeah.
And everything else you're going to do once you get the material, it's all 3D.
Yeah, so if I have a surface area, regardless of the shape, we're talking about 2 dimensions.
It's just a concept.
Well, that got them thinking, Buster.
No, I agree with this statement. If we're talking about area, we're talking about 2 dimensions. Once we start putting depth in it, then we're talking about 3 dimensions. But I can take the surface area of a mountain. That's only going to be described in square footage. It's an irregular shape generally. But we're just talking about the surface of the mountain. We're not talking about the volume of the mountain. Once we start discussing the volume of the mountain, now we're operating in the 3rd dimension.
Physical surface is different than square footage surface. Like when you say square footage, right, or the surface, cubic feetage, and you're using surface in that regard, yeah. But when we're talking about the object and its surface is three-dimensional and it's different. You got to understand the context of surface. It doesn't have just one meaning. You guys should know this.
Which is why I kept saying, the geometric definition of a surface is two-dimensional.
And an object is not a physical object in reality is not a geometric object on a two-dimensional plane. So like a physical ball, like what you believe the Earth is, would have a three-dimensional surface, not a geometric flat plane two-dimensional.
No, the surface is 2D and it's folded in the third dimension.
Making it therefore three-dimensional.
No, it's folded in the third dimension. The surface itself is two-dimensional. That's how surfaces work.
No, surfaces work. You count how many dimensions the surface is in order to determine how many dimensionals the surface is. So if you have a horizontal,
you count how many points of coordination you need to navigate on the surface, and you need two.
This is how you get. See, that's a circle, right? We're looking in the live chat. That's a circle. That's not a sphere. In order to have a sphere, you would need three dimensions to that. Yeah, I am. That's what separates a circle and a sphere is that third dimension.
Yeah, because now we're talking about the volume, but if we're talking about the surface of a sphere, we're talking about
we're not talking about the volume. No, the volume is.
Because now we're getting into manifolds, aren't we?
No, we're talking about the three-dimensional surface, right? The container of that volume, and a container has to be three-dimensional, right? That ball is a three-dimensional container of your inside. That's how that inside can be determined, because the outside is you have cubic feet inside. The only way to contain cubic feet, which is three dimensions, is with a three-dimensional object or container, which would be the sphere.
Now we're talking about volume again.
The volume of the surface. That's what that is. You can't just take you're taking a three-dimensional area, 38 cubic feet, and converting it to square footage, and then saying that area is two-dimensional. That's crazy.
So I put up, a reasonable definition. This is what is accepted in maths and geometry as my example. So show me where I'm wrong.
We showed you. You're looking at a circle, not a sphere or a ball, and you're looking at a circle on the screen because that's two-dimensional. Once you pass from circle to sphere, you are now in the third dimension. You can't then go back to the two dimensions, because there's two different formulas for figuring out the surface of a sphere and the surface of a circle. So you can't flip back and forth between them. That's ridiculous. Again.
It is
But you're never going to change your mind.
Circles, so the surface of a sphere is just 4 circles. So that 2D is acceptable because it's just 4 circles. But the fact that it's non-developable is the bit of a problem with it being 2D. Right? Have you worked that out?
In mathematics, a surface is a generalization of a plane. Unlike a plane, it need not be flat. That is, its curvature need not be 0. Mm-hmm. This is analogous to the curve generalizing a straight line. There are many more precise definitions depending on the context and the mathematical tools to analyze the surface.
Yeah. You know what a non-developable surface is?
No. Educate me.
It's a surface that cannot be expressed on a two-dimensional plane without distortion.
Like that of a sphere?
Yeah, like a sphere. A sphere has a non-developable surface.
What about a cube?
Gauss. A cube is it's developable, right? It can be expressed on a two-dimensional surface.
What about a cone?
Without distortion.
Oh, a cone can, yeah. Too. A cone's a developable surface. I'll get it for you.
Yeah, you just unroll it, right?
Yeah. Gauss that. Wolfram. So it's the developable surfaces. Do you trust Wiki?
I don't know. When you first said it, it sounded like a made-up word. Developable.
As I say, I'm not going to sit and pretend to know stuff I don't. I mean, geometry is not one of my strong points, but you know, definitely remember being taught the basics, and that was one of them.
What they?
That all
taught you-
surfaces are two-dimensional,
Wow.
and you know, three-dimensional objects always have depths. But we don't express surface with depths. We're only dealing with two dimensions. Topological surfaces. In topology, a surface is generally defined as a manifold, a dimension of 2. This means that a topological surface is a topological space that every point of its neighborhood is homeographic to an open subset of a Euclidean plane. Yeah, but this is all semantical stuff.
Well, it's mathematics, isn't it? They can't really call it semantics because I mean that's how you use the words, right? That's the whole point of you using these words to define the thing that you're talking about.
And all surfaces are two-dimensional by definition.
Definition of look. Spheres are
Back to
non-developable surfaces under any metric, as they cannot be unrolled onto a plane. Now, a plane is a two-dimensional surface.
But that's when they get into topological surfaces.
That's where you've got a difference between your two-dimensional surface and the plane two-dimensional surface.
And as it states,
where one says it cannot be unrolled onto the other one, but they both can't be two-dimensional surfaces, obviously.
That's why it says in topology, a surface is generally defined as a manifold of dimension of 2. This means that a topological surface is a topological space that at every point has a neighborhood that is homeomorphic to an open subset of a Euclidean plane.
Yeah, with an extra dimension. Z.
No extra dimension. There's no Z dimension in that.
Of course there is. The Euclidean plane, right? If you're after topology, then you need Z because the Euclidean plane is the X and the Y. Plane, 2 dimensions.
Yeah. The surface is a Euclidean plane. That's what it's basically saying in that statement. It's an open subset of a Euclidean plane. So I don't know. I mean, that's my understanding, and I'm not going to push it because I think we've belabored the point
surface of a
enough.
sphere is most definitely not a Euclidean plane, right? That's the difference.
Well, I'm talking about a topological surface. The Earth has topology, and
Mountains and valleys.
I'm particularly talking about, you know, the model that we have for the Earth that is generally accepted is that it's not flat; it's a globe, and this is what they're applying that to.
No. The elevation or the topography, whatever you want to call it, is a change in elevation. That's measured with a tool called a level, which establishes a horizontal plane of reference.
Now you're moving into the volume. You're moving into the third dimension.
I'm just telling you how we measure the change in elevation.
In 3 dimensions. Yeah, I agree. Because 3 dimensions is an elevation. So we're taking that extra point.
3D, right?
But the
raise
surface
up
of that
the
mountain
dimension.
is only 2 dimensions.
Yeah, but I
No,
think what
it
Bev is
isn't.
saying is it's expressed as a plane rather than a sphere. That topology you're talking about.
Well, a plane doesn't need to be flat. That's basically what that's saying. The plane can have curvature.
Come on.
Back to the top of it again.
Wait, what? Did he say a plane can curve?
In
Yeah.
mathematics, a surface is a generalization of a plane. Unlike a pure plane, it need not be flat. That is, curvature need not be 0. This is analogous to the curve generalizing a straight line. There are many more precise definitions depending on the context and the mathematical tools used to analyze the surface. Because we're only talking about the surface, we're not talking about any depth.
So I had to go and take me Mrs. a brew, and she went, "Are you talking to a dick?" Just be able to hear raised voices.
I think I've raised my voice.
No, she wouldn't be talking about you, would she? Well,
Ah, okay. Hope not. Don't feel I'm being a dick. I feel I'm being quite generous.
you've just said a plane doesn't have to be. What did you say?
In mathematics, a surface is a generalization of a plane. Unlike a pure plane, it need not be flat. That is, curvature need not be zero.
So you're curving planes now. And then when it says that the surface of a sphere cannot be expressed on a plane without distortion, you're saying, yeah, it can be. It is a plane. You don't think the surface of a sphere is a plane, do you?
You're now mixing stuff up. We're talking about being able to represent something on a flat surface. So I can still take a straight line, and if I take that piece of paper and bend it, that line is still straight, even though I've deformed the surface that it has been drawn upon.
Developable surfaces, yeah. You're not saying the surface of a sphere is a plane surface.
But is that line, now I've curved the paper, you know, I've drawn a straight line.
Yeah,
I've now
developable
deformed.
surfaces,
Now I've
yes.
deformed the surface.
Yes,
Is that line still straight?
We're talking about non-developable surfaces.
Does it
Do
deviate
you
to the
think,
left or right anymore?
do you think the
No.
surface of a sphere is a plane surface?
No, I believe it's what I've defined it to be, as I've said from the specific definitions that I've just used. We're talking about a topological surface, which is what the Earth is.
So you're talking about the Earth now, not a sphere.
No, I'm just talking about topology and the Earth.
We
For
were
me, I believe
talking
it's
about
an
the
oblate
surface of a sphere,
spheroid.
though.
Because I think we've got lots of evidence to show that's the case, and mainly most of it is, you know, nice telemetry data that we've collected from above the surface of it.
That's interesting about you. But we were talking about the surface of a sphere. Do you always relate spheres to the Earth?
No, I relate oblate spheroids to the Earth, but that's just my choice.
So when we were talking about the two-dimensional surface of a sphere that you think, can you say, would you be okay with working some way for you to be able to say the surface of a sphere is some sort of a plane surface?
It can be expressed that way as a manifold, yeah.
Yeah, I think you're mad.
Cool. You know, all surfaces are two-dimensional. Until someone can show me good rationale why not, then I'm going to take the current definition that I understand under mathematics and what I was taught as a kid.
Semantics.
Not
You
semantics.
take the semantics. rather than
Definitions.
Reasoning.
No, definition. You said definition was important. That's how it's defined. A surface is defined as a two-dimensional.
Yeah, at the beginning, when you're doing plane geometry, yeah, of course, because it's a plane geometry. But when you get into book 11, turn into solid geometry, then the surface
Now we're
is
talking
that
about
which
three dimensions.
bounds the solid.
Yeah, the surface bounds the solid, but the surface itself is in two dimensions, unless you can show me where it states otherwise.
It states that the surface is that which bounds the solid.
And the surface
The
of
solid
any
has
object
3 dimensions.
and any object in reality that we deal with has 3 dimensions, but the surface of it is a two-dimensional
Not
construct
exactly,
that we
though,
use
right?
to define the volume.
The surface of a cube, like you said earlier, is two-dimensional. It's squares. The surface of a pyramid, triangles, two-dimensional.
Why are those why is those surfaces two-dimensional?
Because they're plane surfaces.
So you're saying that the only
They're
surface that
two-dimensional
you...
shapes.
Wait 1 second. I just want to get you to state this. So you're saying that the surface can only be classed as two-dimensional if it's flat.
Two-dimensional, yeah. It's a plane surface. That's what two-dimensional
So
is.
what I would like you to do is to show me any object in reality that actually has your definition of a surface.
A two-dimensional surface. It's within mathematics, right?
Yeah. All surfaces in mathematics are two-dimensional. Yeah.
Surface, yeah.
Yeah, but that's an abstract. What I'm asking you to do is show me any object in reality, any three-dimensional object in reality that is flat.
Flat
That has a flat. That has a flat surface. Yeah.
A visual.
Yeah.
Like
that
as in
does
flat.
not deviate from an absolute zero. Yeah.
Oh, right. You flat, not just the visual signifier.
No, a cube. Any square, cube, triangle, whatever. Give me any one of those where you can actually show me that that plane does not deviate from zero.
Okay, so that you would call that two-dimensional, right?
No, I'm just going with
You
your
say it's
definition that you've just gave, that we can take,
Yeah.
real cube,
Okay.
and, that real cube, the surfaces of that cube, you can say that surface is two-dimensional. I want you to show me a real object.
Okay,
That has that level.
You might have missed this
that
before.
level of precision.
You might have missed this before, but two-dimensional is a conceptual thing, not real. We live in reality.
So a cube doesn't have a developable surface then?
A cube, right, mathematically, is a three-dimensional object that has squares as the surfaces. Those surfaces are two-dimensional mathematically.
But you can't show me one. You can't show me one of those in reality then.
What, a cube?
A true cube, yeah.
Have you seen a Rubik's cube?
Mm-hmm.
Well, I can show you one of them, can't I?
Yeah, but are those?
You say that's not a cube?
No, I'd say that's not a cube. That's not a true cube because the surfaces are not flat.
So they're not 2D.
No, that's your definition of it, not mine.
No,
I said the surface of any object. So if you're dealing with the surface of any object,
spent too long arguing about bullshit over
any object
gems.
is two-dimensional.
Talking about a surface of two-dimensional things is conceptual.
Mm-hmm.
Yeah, it's not real. When we're talking about it, we are talking about it conceptually.
Mm-hmm.
Right.
I agree.
2D.
I agree.
Okay, so there is no 2D in reality. It's just a conceptual idea.
I agree.
For you to understand the proofs of geometry, so you progress into solid geometry,
I agree.
reality.
I don't disagree with anything you've just said there, because all surfaces are two-dimensional, because it's an abstraction
there's
from
no
reality.
2D in reality. But you're now going to say everything that you see is 2D, not real.
I'm not saying that. I'm just saying that when we deal with the concept of a surface, by definition, it is two-dimensional.
So in reality, it's not, because there's no such thing. So it's in reality, it's 3D. Yeah?
Yeah. Don't have a problem with that. I mean, again, but what I'm talking about, when we are looking at
I don't know what the argument's
concept...
about then. Why have you been arguing for something?
Yeah,
that
there is no
real?
argument. It's done. You guys
Thank
agree.
you very much, Gus.
Yeah. So we agree that all surfaces are two-dimensional. Okay.
Conceptual in your mind, but not
Yeah.
in reality, right? In reality, everything's 3D. Thank you very much, Gus.
Cool. The only point that I was making is when we talk about the surface of an object, that concept, it's always in two dimensions, regardless of its shape, whether it's regular or irregular.
Yeah, you can think whatever you want, Russ.
You just said it.
Said you can definitely.
I just want to apologise to the room that it took so long to get any sort of concord on that.
I don't think you got the result that you were hoping for.
I'm not expecting to change your mind in any way, shape, or form, Bev. Let's just make that straight. I was making a point and I stuck to it. That's the only thing that I've done.
Yep. And you gave it up in the end. Thank you.
No, I didn't. I agreed with you because you then came to the point where you basically agreed with me that when we're dealing with the abstract of two dimensions, the concept, because I was taking you into platonic objects and you kind of knew that, I think, which is why you backed off.
We were talking about
guess.
reality, Dross. We always were. We were, yes. You weren't. You were living in your little abstract world.
But you're
all
now
the
saying
time. We're talking about reality.
Yeah,
We-
I was
we
talking.
said
I was talking about the concept
said
of two dimensions
mountains.
in our reality.
Yeah, we said balls and mountains. They exist in reality. You've agreed it's
Mhm.
not 2D.
Yeah, I've
Yeah,
always accepted that.
very
But
much.
when we discuss,
So
the
I don't know why
surface,
I don't know why we're
when
still
we
going on
discuss-
about this, Trust. It's over. Everything
when we
in
discuss
reality
the
is 3D.
abstract of the surface,
Yeah.
we're talking about 2 dimensions. That was the only point that I was making, and you agreed with me. I'm cool.
No, I didn't agree with you. I agreed that a 2-dimensional object or whatever is a mathematical concept, and it is a plane.
And a surface, by definition, is in 2 dimensions.
A plane surface is a 2-dimensional surface in mathematics. Just
A cylinder, in mathematics,
It's-
the surface of a cylinder is a 2-dimensional abstract.
because in mathematics it is a developable surface.
Show me where the surface of a non-developable object is not considered 2-dimensional, and I will accept your argument.
Okay, hold on. Let me
Yeah.
compare to. So you in 2 dimensions, that is the conceptual, right? Conceptual is 2 dimension. Reality is 3 dimension. I feel like you both at least agreed on that. Now the surface of objects in reality, right? Now we're it's like, oh, it's surface, but it's in reality. So if it's a surface, you're going to say it's 2D, but it's in reality, and everything in reality is 3D, and this is where the mix-up is happening.
No, what it is, I mean, for me, right in the hand, it's quite simple. Is that when we're talking about abstracts, like sort of area, so we give labels to shit. So an area is just our definition of a space. When we're talking about the surface of an object, we're not talking about any depth. Depth is required to take you beyond the 2nd dimension into the 3rd dimension. In mathematics, this was my point. So any surface that we deal with, we're not dealing with any depth. Therefore, by definition, we're dealing with 2 dimensions, not 3. That was my
unless the surface wasn't in the conceptual mathematics and it was in actual reality, then the surface of a cup or the surface of my hand is 3-dimensional.
No.
Well,
Unless
no.
you're
Dimension.
wait. So now you're going to say the surface of my body is 2-dimensional, and I am a
No, the
2-dimensional paper being flopping around.
No. The surface of your body is an abstraction that we use to describe something that doesn't require us to deal with any depth. So we are discussing 2 dimensions. When we're discussing all of your body, the volume of it, as soon as we start getting into depth, we're now moving into the 3rd dimension. That's all I'm saying. It's not really complicated, and I don't know why it's so.
Yeah, I think it goes back to,
Hold it.
like you said,
Always
the topology,
surface,
right?
there's no height. So there's only 2 dimensions to navigate on the surface because you're never leaving the surface.
We're in 3-dimensional space, though. So you can see
Doesn't matter. You're traveling on the surface, Beth.
Developable surfaces, which can be realized in 3-dimensional space, include, and it goes through the developable surfaces because they can be expressed on a plane.
If
That's
you're
a
traveling on the
two-dimensional
surface,
surface.
you only need 2 points of coordination.
Developable surface, right?
Bev, you're
The
not
sphere
listening.
is not.
If you're navigating on a surface, you only need 2 points
And
of
when do you
coordination
navigate on the surface of a sphere?
on the surface.
When do you do that?
When you walk through the street, for example.
Well, we're
Are you-
talking
are
about
you
a
kidding me?
sphere in mathematics. Now, do you
Yes.
often navigate on like cones and pyramids and cubes? Or is it only when you come to the sphere that you have this thing where you have to turn it into a 2-dimensional?
No, all surfaces are
Imagine it.
2-dimensional because you're not leaving the surface and you only need 2 points of coordination.
Yeah.
It's
Yeah.
a definitional thing. That's all we're
already been
talking about
tried
here.
before.
No, yeah, and it works, Beth. You're simply
We're
wrong.
talking about in reality.
Yeah, we are talking about in reality. If you're not leaving the surface, you only need 2 points of coordination.
It's no different to me saying if I give you 3 apples, then you'll know how many apples that you have, even though 3 is an abstraction. It references to something in reality. That's all a coordinate system does. It references to something in reality.
Well, right. I don't know why you're talking about coordinate systems. We're talking about dimensions.
No, we're talking
not
about
coordinate systems.
We're talking about 2 dimensions, and we're
Yep.
talking about how you can represent a location on a surface, and a surface by definition is 2-dimensional, using those 2 coordinates. That's all you need. You don't need any depth.
I would say specifically you guys are talking about topology in mathematics. And yeah, like you said, the what did you call it? Homeomorphism?
Homeomorphic, yeah. Yeah,
Yeah.
kind of.
Well, if you're going on a surface, like you say, you can go up, down, or left or right on the surface if you're talking about the surface. If you're going through the surface, okay, well, then it would have 3 dimensions. It has 3 dimensions anyway. But normally when we talk about a surface, if we're going through the surface, we're going below the surface and no longer on the 2D-ish topography of the surface itself.
That's not what we're talking
anyway.
about, Lemon. That's
So
completely different.
conceptually, it would be 2D since you're going along the surface in more or less 2 dimensions, up, down, in, or left, right. You're not really going through it. So it just depends on how you want to define the surface and how you're going over or through it conceptually.
Well, we're defining it as just the surface, on the surface, not from the surface. So only 2 points are required to navigate on the surface, meaning it's 2-dimensional.
As soon as you start talking about height, you're no longer just talking purely about the surface. You're now talking about the 3rd dimension.
So a sphere doesn't have height, does it not?
The surface doesn't, no, because otherwise we'd be dealing with 3 dimensions.
So you wouldn't say that a sphere has a height?
No, I'm saying that the surface doesn't have a height,
how would you
but a
define
sphere
it?
has a volume. Now I can say
This
that
is
from
point
the
we're trying to get
center,
to, right? Are we talking about a sphere conceptually in mathematics?
no, we're talking about a surface conceptually.
We're talking about a 3-dimensional Euclidean
No, we're talking about
shape,
a
the sphere.
surface of an object.
For
is
what
always
reason?
2-dimensional.
For what reason are you talking just about the surface? For what reason?
Because if you use a coordinate system that gives you an X and a Y, then you're not dealing with a 3rd dimension.
We're talking about a sphere with a surface.
The surface,
I'm not aware of us swapping it to coordinates just yet.
Well, I guess that's what he's talking about, placing a location on that surface. Correct, Foolish Decision?
Yeah,
So
yeah,
we're
we're only
talking
doing
about
2D.
something in reality, not mathematical concepts.
Yeah, which is why I posted the longitudinal, latitudinal coordinates of Mabel.
Which is why we just said before,
Almost got a
it's not
sentence out
2D
there.
then.
Yeah, it is.
We just said before, 2D is just a mathematical conception.
Yeah, the surface.
It doesn't exist
Yeah,
in
the surface
reality.
exists. Objects have
concept.
surfaces.
Yeah. The number 3
So then
is a
if we're
conception.
talking about reality, we're no longer talking about that 2D, right?
Yeah, we are.
It's not a measurement. It's just a concept they have mathematically to put these locations on a sphere, because they think the Earth is a sphere, so it's okay for them to conceptualize mathematically a location on that surface of the sphere.
Yeah,
and that mathematically that works, and it's just a concept. There's no measurements involved or anything like that.
Yeah, it's just an
I
idea
totally
in their
agree with
head.
what
It's
Flat Earth Egypt just said.
imaginary. Yeah, it's you're doing
No, it's not imaginary.
imaginomics.
Surfaces are reality, Beth. There are surfaces in reality.
But then they would be 3-dimensional.
No. If you navigate on the
They
surface,
would stop being conceptual.
if you navigate on the
Reality.
surface, you're not deviating in height from the surface, which means there's only 2 points of coordination necessary to navigate on the surface, making it
conceptual.
2-dimensional.
He's still got it conceptual in his head.
No,
It's not real. You're just imagining
it
it.
is real because surfaces
You
exist
can
in
imagine
reality.
it being real, but
3D
it's
in
still
reality.
2D to you, which means
Yeah.
it's not
Because a
real.
surface is 2D, and surfaces exist in reality.
It's no different to me, as I said, going back to my example, I can give Flat Earth Egypt 3 apples. Now, the number 3 is a concept
you
that we
just
use
said
to
that
represent.
before.
Yes, I know. I'm
This
going
is
to repeat
getting-
it.
Why?
Sorry, Bev. I'm going to turn you down, mate, because every time I start talking, you overtalk me.
Oh, that's not going to happen.
Dude.
That's turning back up. That's not
Oh,
allowed
guys,
here at all.
we just make like all of us just
I'm
need to take a
just
step
trying to
back.
get one
Let 'em-
sentence
yeah,
out
let 'em just
without
do it.
him overtalking me.
And I will warn everybody for clipping, even Bev and everyone's clipping. So be aware, but you can't turn people down.
Well,
Cool. Okay, I'll turn it back up.
Carry on.
Thank you. As I say, we use numeric values to represent things, and that's understandable. It's the way that we describe the world around us. You can argue the fact that 2 dimensions is a conceptual thing when we're dealing with the surface of a 3-dimensional object, but it's an abstract that we use that has a value in reality. The same as 3 apples has a value in reality. If I give you 2 apples and I say I give you 3 apples, you're probably going to argue with me.
You know what? Foolish decisions. You didn't give me 3 apples. That's the problem right there.
How do you like them apples?
But yeah. So I mean, again, I think it's a little bit definitional, a little bit semantical, but as far as I'm concerned, when I'm dealing with a surface, I'm not dealing with any depth. Depth is a requirement for 3 dimension to view something in its 3rd dimension. And then I can start looking at the world, so I can then talk the difference in my elevation between me and, the highest point around me. We're now talking about height. So we're now talking a change. If I'm talking about, the amount of water in a cup, I'm now talking about volume. That's because I fancy a cup of tea and I'm about to go and make one.
I'm confused. Maybe you can help me because you're civil about it. You're saying you navigate in 2D, but once you get to that point, you turn it back into a 3D place?
No, it's not that. It's just how we represent, so a grid reference. So,
Right.
say, for instance, we're orienteering.
Right,
and
represent, though, concept, right?
Yeah. But then
Yeah,
I
yeah.
can also, that's it.
Right, it's just a concept in 2D to get you to a point, basically on a grid system. But where we live and where we're traveling and navigating to and from is 3D, correct?
Yeah, I operate in the 3rd dimension, but when I look at a coordinate system, we're kind of representing that on the surface of the object. So we're not really concerned about it because it's just the surface. The topology itself really is immaterial to where that point is, because a mountain, whether it's 10 feet high or 5 miles high, is in the same location on that sphere.
But in your
verticals.
concept, right. The plumb. But in your concept, you're representing the surface of the Earth as 2D, and it's the surface of the Earth is not 2D. It's just in your concept.
No, in reality, all surfaces are 2D.
Okay,
You cannot bring me to
Can I just bring it back to this? Bring it back to the relationship of this representation, right? So in reality, with our grid reference system, right, we can triangulate on those maps, right, with triangles, which are 2D triangles on the 2D representation of the map of the land, right? And that's how we triangulate the positions in the UK in order for us to be able to make those maps. Right, Joss? Now those triangles are 2D.
Yeah, but what we notice when we do those triangles, when we draw a triangle on the surface of an object like a ball, if we do a 3-sided object, it has more than 180 degrees if it's an
on the
equilateral triangle.
maps for the UK, the grid coordinate maps, they triangulated all of the positions on those maps with 2D triangles, right?
I think the answer, Just, that you should be looking for is the fact that the maps, the 2D maps, are projections, and so
the
those
2D
triangles
that are used for triangulation.
Rakia, can we get a warning in, please? That was bad clipping there.
Yeah, it was. Thank you.
So me. Yeah, so the 2 triangles or the triangles that you'd place onto the map, well, if you move them towards the places with more distortion, which would be towards the poles, usually with the Mercator projection, they wouldn't be representing a real triangle in reality, and you would get your triangulations would be off because of that distortion that appears, because it's a projection, not a true 2D object.
Are you implying there's a
Wait a minute, let me
three-dimensional
finish.
triangle?
Hang on, we
Dross.
can't move away from Bev's. Yeah, to
I
Dross.
did ask Dross, and that other guy just jumped in, and Dross rightly said clipping because he just jumped
No,
in
no,
and
you were
Dross
clipping
wanted
him.
to
That's
answer
what I
it.
was saying.
So
He was-
in the UK,
everyone's allowed to make.
representation of the maps
Dross,
that
why
we
are you
use.
cutting off now? Come on, Bev. Ask your question to Dross. Let's let Dross respond, and then we can move on.
In the UK, we use a grid reference system, and all of the triangles that would be drawn on those maps would be 2D triangles, right? And that's how we've mapped the UK triangulation, right, Dross?
Can you give me an example of a 3D triangle?
He just asked Dross a specific question. So if we could have Dross say he wants to answer or not.
Ross appears to be mute or deafened, so he can't hear anything right now.
Oh, that's convenient.
What's a 3D triangle in reality?
There's no such thing, is there?
Oh, so why do you keep it explicitly implying 2D as if there's a third-dimensional triangle that we can refer to?
Well, I was just pointing out the maps are 2D. Those triangles are 2D.
Yeah. Okay.
Yeah.
All triangles are 2D. There's no 3D triangle existent that I know of, at least.
Yeah, and the angles of a triangle add up to 180 because he was saying when you stretch it onto a sphere, they no longer add up to 180. Well, it's no longer a triangle then.
And you can't triangulate with it, which is what
Grid-
the UK did.
The grid systems are 2D, right, Bev?
Mm-hmm. Yeah.
With triangles adding up to
180
degrees.
As always, yeah.
It's only when you stretch that grid system around a sphere that those same measurements would be more than 180 degrees.
Yeah, you have to add in that third dimension, which adds a curve to the plane surface. That's the third
There you go.
dimensional curve.
We finally got the point out, right?
Yeah.
It's pretty simple to me.
And everybody's gone deafened.
Yeah, but that's all right. The point gets out, and that's how it's done. Triangulation using 2D, 180-degree triangles over a grid system. They point these plots, and voila! You also get elevation based on these areas over a grid system, which is based on mean sea level. They mark these out all over the grid system. Only when you stretch that over a sphere does it start getting out of whack.
Yeah, you can't actually have any. There's no straight lines on a sphere, and you can't have a square on a sphere. It just doesn't work. It's not allowed. It's not a shape that fits on a sphere. So the fact that we have grid reference systems with squares.
Ed says you can.
It says you can.
Ed.
Give us a three-dimensional square, Ed, outside of your virtual reality, please.
You mean on the surface 2D?
No. I want a three-dimensional square.
Three-dimensional square.
Yeah, you invoked it. Now bring it.
No, that's not what I said.
Give us a square in reality, Ed. Aside from your little pictures in your virtual reality, something we can touch.
Yeah, sure. Just draw one on the surface of Earth.
I said no drawing. I said something we can touch, Ed. Something tangible. None of your little virtual reality.
You can't touch a drawing.
Ed, you got to step out of the computer, right, into the real world and smell the air.
Yeah, you can draw in reality.
Okay, Ed. So 2D is all you got.
That's all you need for.
2D is all you got, Ed.
That's all you need for the surface.
Can you show us a square of a square, Ed? That was a joke, but anyways, go ahead.
I think the point has been made that his is only a mathematical concept. He can draw it on a piece of paper.
No, it isn't.
That's what you're telling us.
Well,
yeah, because surfaces exist.
Well, he asked you to show, bring me to the 2D surface of Earth. Let's meet there. Where would that
Just
be?
just look at it. Look at the ground.
Yeah, there's
when
depth.
I look
The
at
second
something,
you
it's
have depth,
3D.
Ed, you have dimension. If there was no depth, if I couldn't penetrate what's under my feet, then I would beg to agree
Then
with
you're
you.
not on the
But I
surface
can't.
anymore, are you?
But let's go back to your square, Ed. I want to hold
Then
this.
you no. Let's stick to this because you said you can't
Square
go
one,
into
Ed.
the ground. Well, then you're not on the surface anymore. Then you're in the ground, which means you're under the surface in the volume. That's not 2D,
Ed,
dumbass.
I think the words you're using are a little too big for your britches. Let's stick with square one. Can you show us a three-dimensional square?
I never said I could. That's
So then
something
why
you're
do you
making
keep
up.
invoking that it's not a concept?
Nobody said 3D square besides you.
Okay, so is a 2D square a concept or reality?
What?
Is a two-dimensional square a concept, mathematical concept, or something within reality, i.e. tangibility, meaning we can hold it?
A perfect square, like a perfect circle, is just an ID, but we can get very close to it.
Okay, how about your rhombozoid?
The what?
Your rhombozoid, an unperfect square.
What are you talking about?
You're trying to dance. You're trying to dance away from the fact that two-dimensional square is something conceptual and non-tangible.
No. What is that word you just said?
It's irrelevant, Ed.
No, I have no idea what you just asked me.
I think the word you're looking for is rhomboid. It's similar,
Yeah,
but
that's
yeah,
fine.
rhomboid. Yeah.
All right, never heard of it.
Yeah, it's just a two-dimensional version of what I said. I kind of slipped up on a dimension with the oid. But nonetheless, Ed, this
Okay.
is all concept. So unless you can provide different, then just sit back and buckle your belt.
Well, you're making up stuff about 3D squares and shit, so why don't
No.
you settle down?
Give me a
I
2D
think
square I can hold,
we
Ed.
should all settle. So what did you say about the square, Ed, and the sphere, and the surface of a sphere?
Yeah.
Yeah, what did you say?
What about it?
What did you say
Well,
then? Because
it's a surface, so it's
So-
2D.
A surface is a single dimension, Ed.
What?
yeah, but specifically, what did you say about a square and a sphere?
Yeah,
You
square
said
is
something
2D.
specific.
The surface of Earth is 2D, so there you go. Why is that a problem?
But that's not what you said. I want specific. What did you say about the square that you can fit it onto the surface of a sphere? Is that what you said?
Yeah, because the surface is 2D, so therefore a square, which is also 2D, goes on the surface. Yes.
Of a sphere.
Yes, because the surface is 2D.
And it would remain as a square.
Where do you get the
In
definition of
2D,
that?
on the 2D surface, yes. Now, if you're going to fold this two-dimensional thing in the third dimension, and you're going to look at it from the third dimension, might
Yeah.
look distorted, and you might say, "Well, hold on, that's not a square." But if you look at it from a two-dimensional surface perspective, yeah, that's.
Did you
it's a
never
square.
get out of? Did you never make it to book 11?
Bev, just if you have nothing useful to add,
Yeah, no,
just
this
be
is
quiet.
very, very, very
No,
poignant. It is.
isn't.
It
isn't.
is, yes.
No.
Because up until book 11, you are dealing in 2D. And it's right, a surface in two-dimensional geometry, plane geometry, up until book 11.
Every surface is two-dimensional.
No, it gets redefined.
Yeah, they all are.
It gets redefined in book 11.
No, it doesn't.
Yeah, it does. I've put it in the
Ed,
chat.
you got to wake up, Ed.
I am awake.
It starts
Oh,
book 11
like
starts
reality awake.
solid
do you know how much
geometry.
coffee I had today? I'm very
Solid
awake.
geometry, Ed.
Is that digital coffee,
it
Ed, or
starts
reality
off-
coffee?
Starts off
2D
definition
coffee.
1. A solid is that which has length, breadth, and thickness. That's 3 dimensions.
Yeah, that's volume.
And then it then redefines a surface. It says that which bounds a solid
Right.
is a surface.
Uh-huh.
Right? So If
so
the
not the volume,
object
so not the
is
volume then.
three-dimensional,
No, Beth.
that
No, you're
which
wrong.
bounds it must also be
No, it isn't. It's just 2D.
three-dimensional.
No, it's 2D folded
No,
in the third
that's where you
dimension.
get stuck with the
No,
different
that's where
shapes.
that's where you are getting stuck because the surface
The
is
sphere is a
the
different
surface,
type of shape.
But no, you're
isn't
just
it?
no.
It
You have
doesn't
no
have
idea what you're talking
polygon
about.
sides. It
You have
doesn't
no idea what you're talking about. The
plain
surface is
sides. The
the
shapes.
surface is 2D folded in the third dimension, and the volume, which
That
is
would be true for
three-dimensional,
every other shape
the
other
the,
than
vol-
the
the
sphere
volume, the
within this
volume,
geometry.
the volume, which is three-dimensional, fills it up.
Ooh. I don't know. I think you might be.
Yeah, no, that's how
stuck on
volumes
your
work. They
2D
fill things up.
2D
That's what she
thinking.
said.
2D semantics.
No, surface
Come
is
in-
2D,
come into
and
the 3D world.
the
Come into the
volume
real
is
world,
3D. I don't know why you're having so much trouble with
Just
this.
talking about the definitions. Of
Yeah,
in
and you misunderstand them completely while reading them. It's amazing.
That which bounds a solid is a surface.
Yeah, and the inside of the solid is the three-dimensional part. The surface is 2D. Because otherwise the volume would be 3D, or
I
the
think you're
surface
just
would be the
2D
volume
thinking.
or something.
We've gone.
What are you
you're
even
stepped
saying?
Into
Are you
3D
saying this?
worlds
Are
and
you
you're
saying
wanting
the
to do
surface is
2D?
the volume, Beth? Is that
No.
what you're trying to tell us?
No, the surface.
Oh,
is
okay. So the surface is
which
then
bounds
two-dimensional, and the
the solid.
volume, which is three-dimensional,
Stop
is the
talking all
volume.
over him, spinning.
It's
Please.
Ed. That's what he does. Up against it. All right, Ed. That which bounds the solid.
Yeah, the surface, 2D, and the
solid.
solid inside, which is
No,
the
the
volume,
solid would be the
is
3D.
is three-dimensional. Yeah, that's the volume. That's correct. And the outside, the surface, is two-dimensional.
Yeah, it's pretty simple, this, Ed. I don't
Yeah,
know
it's
why
really simple. I don't know why you're struggling with this.
Yeah.
It's really easy. Volume is 3D. I don't know why you're having so much
Doesn't
trouble.
actually go into the volume there. It just talks about.
Yeah,
the-
in the
it's only-
volume, yes,
only the
yes.
second
But on the
definition.
surface,
Let me bust in for a minute, Ed. If you keep talking over him, I'm going to give you a warning. Just chill, man.
yeah, he's doing the same thing to me, so warn him as well. Or just don't bother me, okay?
Go on. Warning taken. Thank you.
All right.
So we've finished that then. I've had enough of this 2D, 3D.
Yeah, we're
bullshit.
finished. As long as
Yeah,
you're
yeah.
staying on the surface, you're not going in the
In
volume.
reality, everything's 3D.
You're talking through me, Beth. As long as you're staying on the surface and not going in the volume, you're not going in the third dimension, which means it's 2D.
It doesn't work that way, Ed.
That's exactly how it works.
Just let him have it. There's
Unfortunately,
no
your
way he's going to
paradigm
think.
isn't axiomatic. Two-dimensional conceptual mathematics is not axiomatic to the third dimension in reality and observant. Okay, it doesn't work that way. And if it was, Ed, we wouldn't have topography as we do.
All right, so Dyslow, let me ask you then. If you're staying on the surface, are you going inside the volume?
If I'm
Inside
staying
the
on top
volume.
of the surface, am I going inside the volume?
What
So Ed, you
does
got to
that
step
even
out of
mean?
the video game, right?
Can you just answer the question, please? If I'm staying on the
Doesn't make any
surface,
sense, Ed.
Ed,
hold
exactly. Doesn't
on,
make
Beth.
any sense.
Settle down.
Here's
I know
the
you're
thing.
mad.
I'm
But
gonna meet
settle
you in the
down.
middle. I'm gonna meet you in the middle, Ed, and I'm
Just
gonna go
answer,
as
please.
far as to say that if I had an impenetrable surface, right, this could be possible potentially. I'll give you that, but I don't honestly I don't even agree with that. But let's just see what you can do with that.
Right, so if I'm staying on the surface, I'm not going in the volume, which means I'm not deviating from the surface, which means I only need 2 dimensions to navigate on the surface. Because
But what
there's
I'm trying
no
to tell
height.
you, Ed, is if it's possible to penetrate that surface, you no longer have 2 dimension. Your whole
Yeah, you
paradigm
do.
shatters. Your whole paradigm would shatter.
No, it wouldn't. Just the surface would be larger.
The second there was depth to your surface, 2 dimension is shattered.
No, because if you're staying on the surface, you're not going in deviation. You're not deviating in height.
I understand.
You're not deviating in height from the surface, which means
But
you
here's
only
the problem you're missing.
which means you only need forwards, backwards, and left and right to navigate on the surface, because you're not navigating in height from the surface, which means it's only 2-dimensional.
But here's the problem, Ed, is the second
There is no problem.
Listen.
All right,
the
we gotta
second-
let each other talk.
Exactly. The second that surface is potentially penetrable, you just invoke the third dimension automatically, dude.
No, I didn't, because that just makes the surface larger and the volume smaller. If I'm not talking
about the X and Y. I'm talking about the Z coordinate.
Yes, and if I'm staying on the surface, it means I'm not deviating from the surface in height, which means I only need to go forwards and backwards and left or right, which means 2-dimensional.
Yeah, it's a way, Ed. It's just a way. Topology is just a way of mathematically expressing that surface of a Euclidean space.
I don't think
Correct,
Ed. If y'all agree with me, I don't think Ed is going to give in here.
Never.
So
I don't need to.
It's just wasting time, right? We could shut Ed up, and then we
I'm
can
not
all
wasting
have an
anyone's time,
argument
Jeff.
or a
Please.
discussion amongst ourselves without Ed.
You're just in denial. Come on.
No,
Okay,
honestly,
Ed,
I don't
we
think
get
he's being dishonest in any way. Maybe he's
I
just
don't either. I don't
flipping
either.
a
I'm just
little
saying
bit.
I don't think he is going to give in.
this
So
is
why are
what
we going to
happens.
argue all day with it?
Yeah.
This is what happens when you have AI mixing with humans. Ed is a robot,
let's
and
not
he
get
lives in
personal.
virtual reality.
No, there's no need for that. Let's move on. So, I personally think that Ed is talking about a conceptual surface because he can draw it on paper. He can put a. Hang on, Ed. Don't clip me, please. So the way I'm hearing it, he could put a coordinate to that surface on paper. But when we actually went to that coordinate, we would be on a 3D. We would be in 3D. So I don't get. I understand where he's saying that surfaces are 3D when you talk about them in concept or in mathematical terms, but in reality, that surface of Earth where we're at, where we live, is not 2D.
Yeah, it is. The volume is the third dimension. I don't understand why you're struggling.
We heard you.
Yeah.
All right. Well,
you,
then
Ed.
let's move on to another topic.
I agree. We disagree, and that's what I'm saying. I don't think you're ever going to give in, nor are we. So let's just move on.
All right. Next topic.
Actually, I'd like to have a finishing statement. You should get the right to do that, right?
Absolutely.
In reality, which is where we deal with most of the time, all of the time, we use geometry to express that, but it's to express reality. Now, we're always talking about reality. That's why we say it's a 3-dimensional surface.
That's why you're mistaken.
And a square, a triangle, they're a circle, they're 2-dimensional shapes. They're geometrical conceptions, as is a cube, the perfect cube. And they just so you get a vision in your head of what it is we're talking about. They're descriptors, but the geometry and the mathematics all work because the principles of that work. They're just a conceptual thing. The 2-dimensional geometry that everybody thinks about with triangles and squares and trigonometry and all of that. That's 2-dimensional. The moment you step into 3-dimensional solid geometry, then you use all of those ideas and conceptions and proofs and translate it to reality, the actual 3-dimensional Euclidean space that we live in. And that's how you use it.
Yep. Volume is 3D. I agree. Let's move on.
Yeah, I agree with Bev. Definitely with that closing statement. 100%.
And if anybody else is at any sort of conceptions about what the difference between 2D, 3D, I invite you to have a chat. Speak up, everyone. Because
we were going to move on from this topic.
Ed seems to make
Bev,
it.
Bev,
No,
Bev,
Ed,
you're trying
please,
to
Ed,
talk about
please.
this for another 15
I
minutes,
said,
but
yeah, I'm just trying to
move
say
on.
how you like to obfuscate. There's
Well,
loads
you're
of
not.
people
No,
that like to obfuscate this.
that's not going to happen because that's
Very
what you are
simple
doing,
concept.
actually.
Ed, please.
Look, can I ask Ed a question?
Go ahead.
Does Mother Nature do anything in 2D at all, Ed?
What?
Does Mother Nature
I have
do
no
anything?
idea how to. Yeah, I heard your question, man. I have no idea how to answer that
Does
because I have
the
no idea what
natural
the topic
world
means.
does the natural world on its own, right? Reality itself, the natural, yeah, our reality. Does that do anything in 2D? Is there anything
Yes.
two-dimensional existent?
Yes, and I can give you a very good example. Feathers. They have an incredible large surface. That's why birds fly. Or one of the things why birds fly. Because feathers have an incredible large surface.
Oh, okay. So if I could create some two-dimensional bird feathers for me, I could fly, is what you're saying, Ed?
No, I'm talking about the surface. I didn't say bird feathers itself were two-dimensional. I said the surface of the feather.
Yes, and that's the whole point. That you can express the surface of a feather in 2D, but the feather itself is not 2D, correct?
The volume is 3D, but the surface of it is still 2D.
Correct. I mean, you can mathematically express
All right.
the surface.
Can we please move on? Because this is going in circles again.
Yeah, it is. It's fine.
Sounds like you walked yourself into a hole, Ed.
No,
Does anybody have a
Is that a
topic we can move
two-dimensional
on
hole,
to?
Ed?
We're
Die
kinda
slow.
stuck.
Just quit it.
So, does anyone have a topic?
Yeah, I want to talk about Rumpus and Ranty doing their test, because that's in reality, right?
Yeah, that sounds interesting because I don't know much about it. I'd like to hear about it. If everyone's fine with that, yeah.
Sweet. Well, the Rumpus one is Bedford Levels. Have you heard of that?
Yep.
Bedford Levels, but you've got Robotham, who did he got a telescope. He was 8 inches above the water, looking from one bridge while a guy sailed away in a boat, and he was looking at it. He was the only one in the middle, and he said he could see the guy in the boat all the way. I doubt that very much. And then Wallace apparently went back and measured the hump. So that's, flat and then a hump. But Rumpus, taking George's advice, is going to look for the drop of the water level.
Tell us more.
That's right. The drop of the water level over distance. Rumpus.
Yeah, the methodology. How's he going to do that?
He's going to have an auto level. I'll live stream 2. I'll show you. He's going to get an auto level. Let me show. Yep. He's going to get an auto level, and he's going to look down Bedford Canal, something like that. So
And look for the drop of the horizon, basically.
of the water level.
Yeah,
because it's a canal. Yeah, it's locked up. It's sort of. So yeah, he's gonna measure. Well, not measure. He's gonna put a pole up. Right, I'll get you the pole. Here we go. He's going to put a pole up at the far end. There we go. Like that. Right? He's like as you're looking down the canal, right, through an auto level, like you can see there. Rumpus is going to put that pole up down at the far end, and he's gonna measure. Well, not measure. He's gonna say the water level drops. I think.
Yeah, so no actual measurement, just like a.
Let's put a poll up. But yeah, so I've got there's another one. Here's a picture. So that's a P1000 camera on the bridge, because we went there on last Sunday, a few of us. So there's a picture of my lad and a few of us taking pictures down that canal, right? So that little picture at the bottom is him taking the picture, and he's looking down that canal, and you can see at the bottom there's a bridge that's like 6 miles away, and the sluice gates are a little bit beyond that, and you can see the water going all the way up the canal under the bridge. And if you can imagine, Rumpus would be on the right hand side somewhere with his pole, and that he's going to show that the water level drops over distance. That's right, drops. As in,
Forgive me, man. I'm just because I'm kind of new to this. I don't know about his test. What's the pole exactly supposed to be doing?
I don't know. Like George, Rumpus will be making a video about it. Something, like somehow it shows that the water drops.
Egypt, are you familiar with George's observations that he did at the lake?
No.
The ones where he got the water to rise above the crosshairs. Those observations.
Nope, no idea.
Have you never seen that? Have you ever
what was his justification for that?
Getting the water level to rise above the to get the horizon to rise above the crosshairs. There you go. Rocky has got it there. I don't know. Yeah, I don't know. Rumpus has been advised by George. Oh, by the way, that auto level shot that mine one was a 32 times scope, the one where we did it at the weekend, and you couldn't see fuck all. Well, Rumpus has only got a 24 times scope auto level as well. So
Yeah, but in yours it was pretty foggy, wasn't it?
well, you call it foggy, but that's what it's like when you're looking.
Are we talking about the one with the bridge or the one with a little bit of height on?
Well, no, the
canal?
bridges. That's an infrared P1000.
Oh, yeah. The one with the auto level is the
one with the crosshairs in it.
Yeah. Which to me looks foggy.
Yeah, it probably was a bit foggy. Yeah, but I mean, you can see the difference between the P1000 where you can see the bridge and that one. It's only a 32 times scope. I mean, the difference between the two is massive. But you have to have experience with a P1000, to see the difference that a P1000 will bring to a camera shot above a 32. Well, Rumpus has got a 24 times scope.
So, in your opinion, like the Bedford level as a test, is it possible to actually do it in a way that shows either way? Like, is it a proper test that we can establish anything from, or is it just useless?
Well, to me, level is horizontal, right? And the proof's everywhere. It just depends what you accept. Now, when we went there, I'll get a few more pictures. When we went there, I seen some stuff on the. Oh, there you go. So this on the other side of the locks at the end. And you can quite clearly see it says 4 and 5 and 6 meters. So that's the scale, right? That on that side there's the River Ouse, and we're talking about Bedford. It's low-lying, low country, so they had to drain it, and the Bedford levels are like a drainage program to reclaim the land from like a marsh area. So there's a pretty complicated sluice gate system to stop this river from affecting the Bedford levels because it's lower. I'll show you in a minute. But so these are marks, and we're talking to the fella that's there because this sluice gate thing's pretty important. They have a guy that lives in the house, and he controls all of these sluice gates and everything. So those markers there are referenced, as he said, to Newlyn, way down south. The mean sea level for the UK,
Oh, okay.
the entire
Uh-huh.
UK. So that's 4 meters, 5 meters, and 6 meters. And he has to report if the weather gets bad, and because it's a River Ouse, it's tidal. So if they get really bad conditions, that can go up quite high there. And the guy's in charge of stopping the water from going on the other side, right? So on the other side of that, on the other side of the thing, there is this, which is a marker, obviously, because there's a lock system and everything, and the sluice gate. That's 3 meters, 2 meters, 1.25 meters. And that's the height of the water on the inside of the river, right, within the Bedford level. So that effectively is the height of the water above the British mean sea level, 1.25 meters. Reference to that 1 point down south. Like one. So I'd say that it's, like an elevation change measured from a tool level on a vertical scale. Like there's no curvature to it. It's just up and down. And all of the reference points of the entire UK are reference to that 1 point. So that's the level of the water.
Yep. That's your starting point.
Yeah, that would be your
argument, right?
Yeah. So the water's level, and it's all at 1.25 all the way across. Reference to the mean sea level of the UK. And there's plenty
I
of
appreciate it when
benchmarks.
you were asking. So what's the curve? How do you establish the curve? That's exactly what you're saying, right? This is level.
Yeah.
This is how we measure level. How do you measure curve?
There's no definition. Have a brief think about it, right? But don't think about it too hard, because it's not up to you to define a curve. It's dead easy to define the straight line and the horizontal and the vertical and the right angles and the trigonometry and all of that. Dead easy. How do you define a curve? It's not as easy as you think.
Yeah, well, their attempts, you get these the dichotomy, right? The hump and the drop, right? These are the dichotomies.
Yeah.
Of their argument.
Or
the attempted definition. Yeah.
Yeah, you can't have a drop and a hump at the same time. You can't have something goes up to come down that is always going down and away from you. I don't know. I can't get my head to do it, and if I can't work a solution out in my head, then it's likely not probably, but you get a lot of people that just tell you it is, it has to be, it must be.
Did you just say it can't be real because you can't imagine it?
Pardon?
Yeah, you
Probably
heard
not.
me. Get over yourself, Beth.
You might have just
You're no, but
misinterpreted
seriously,
it.
you're not that smart.
Doesn't the word imagine or imagination mean that something isn't real?
Well, let's just stick to the argument rather than these comments.
Yeah, Ed's just trying to derail because that's all Ed does. Right, Ed?
No, I just gotta check you know.
Yeah. To
Yeah,
point out to
exactly.
everybody
You're
that
proving his point.
we went to a debate server to go and have a chat with some people, and Ed came over, started calling us names and everything, causing a right.
No, I didn't start calling names. Come on, don't lie.
Yeah, in the chat, of course you did.
No, I didn't. Don't lie.
Was that the open debates server where I met you
Yes.
guys that night?
Yeah, I've got that one. That one's on the cutting board. That like 5.5 hours. We've got to put that one out.
What happened at Blues? I was really enjoying those PhD Tony clips.
Yeah, Blue didn't like us doing that. They seems to have put the word out, and Blue's banned us. Even though it was dead amicable and we were trying to be nice and just having a conversation with people.
Yeah, I saw his reason for banning you was because it's not a flat Earth debate. Debating flat Earth is against the rules.
We said it at the beginning. I was the one that was reminding everybody to stop bringing the Earth into it because we were just having discussions about Blue stuff. Everybody else always wants to bring Earth into it.
Not to like kind of derail the conversation, but what did you think of the debating format of that server and how you can start a debate and people vote and all that? I know it was tiring
Never
and
gonna
it
kick off.
Mind your brownie points. You don't want to lose them. Or
Yeah. They were too keen on their points. I mean, it wouldn't be bad. I'd like to go over there, give them one more chance and see what it's like. Give everybody a fair chance.
Well, we were kind of like, I was talking to Gio and we were kind of, everyone was trying to brainstorm ideas for this server and how to keep the room under control. And like implementing something close to that where, yeah, if you want to start a debate, people might be like get muted if you get like have an audience, right? And there are people who actually participate in the debate, things like that. It would just be interesting if you can have a system like that in here. Maybe not so complicated as that one, which it pretty much isn't if you get the hang of it. But yeah.
Debates would be fine if it was structured around a thing, not just like an instantaneous, I disagree with you, let's go into a full-on debate thing, because that's not what debates are. Like, have you tried using the stage thing yet?
Yeah, the stage thing is pretty cool. It's actually been mirrored off of, I don't know if you've heard of things like, was it Clubhouse and things like that?
Yeah.
These debate apps. They're pretty much, this is where the idea came from. Raising your hand and things like that.
That sounds good. That would probably work in the debate forum if we were to have proper debates. But I've been a big proponent. There's no debates. You've been fooled by some Discord server names.
Well, we're using it in a colloquial sense.
Yeah.
of the term, but
Discussion and like a few debates would be good, but I don't think anybody would have the stuff to be able to bring. I mean, you saw what that open debates was like.
Yep.
I don't know. You'd struggle to find a topic that somebody could actually debate about. Although Ranty could crush us. So that might be good if you could get Ranty on as a debate. How about that? I'd debate Ranty if he came here.
So Ruif was in here last night telling us that the reason Ranty hasn't done his observation yet is he's waiting on us.
Yeah, to predict. He wants some
Make a prediction?
high-level flat earthers to predict something. Yeah.
We're scared to make a prediction.
Yeah. Well, I'm not going to go to the toilet until you guys predict how much volume I'm going to piss. And if you don't, then I'm not going to go to the toilet, and you a lot of cowards. Because that's what they did. They just call you names for not predicting something that they want to do in their little games. I think it's the average group in the UK, like Jeeves and Worcester, these high class people, they've got too much money, and they don't know what to do, so they play little games and get people to do things for a laugh. I think that's what this is. I think somebody said, I bet you can't get a flurfer or somebody to go up a mountain with an auto level. And they go like, no, nobody'd ever do that. It's like, oh, I bet I could. And I think this is just Ruhif's game that he's playing with Ranty. It'd be great. I think it'll be marvelous. I want him to get a statue. I want it to be a new sport for Globers.
Did you make a prediction, Bev, or no?
I predict that Ranty won't do it. But he might get a day out with cats.
Sure. So, okay, that's the answer then.
Yeah.
You don't want to predict.
I really want him to do it.
And what do you think he will show when he does it?
I don't think he'll do it, but I don't think he'll be able to see Blackpool Tower or the Isle of Man.
Okay.
So I don't know how you would predict what you'd see in relation to the Blackpool Tower and the Isle of Man when you
Well, you just said
Blackpool Tower or the Isle of Man.
Your prediction is he won't see it.
Yeah, and he won't do it.
Right.
Because
but that's
if you don't
their
do
prediction.
it, you're not going to see it, are you?
That's your prediction.
Yeah.
What's the distance on that again?
It's 25 miles to Blackpool Tower and 90 miles to the Isle of Man.
9 or 19?
90.
90. Oh, okay.
90, yeah. Yep. You're talking like, I don't know. Like, what's the furthest distance you've ever got with your photography? Anyone?
Me? I got the moon. I got millions of miles away.
Nah. Terrestrial. Looking like horizontally.
I know. I'm just bugging.
Yeah.
Well, in that picture they're always using, that guy used a 600 millimeter lens, I believe.
300 millimeter with a 2 times. Yeah. Yeah, he says that, doesn't he? He's a photographer. And that's only at 900 feet as well, I think it was, wasn't it? So that wouldn't be up Winter Hill. But good luck to him. I mean, he says he's bought it. We was chatting the other day on Limey Plays channel where they were, chatting. They were drinking, him and Limey. He's bought it and he's going to go on the train and go and see Cats. And then him and Cats are going to go up Winter Hill. More predictions. Have we still got the text chat trolls? making people want predictions. You know, what do you call a prediction with absolutely zero experience? What's that called? Is it
They have a
still
name for it.
prediction? Can you class it as a prediction?
Mystic Meg. Crystal ball prediction. I don't know.
It's like based on pure imagination.
Well,
just
yeah,
cur-
exactly. Because in the way they frame it, it's kind of like a scientific prediction, right? Which it's far from that.
Yeah, what's up with the prediction thing? So what if you get the prediction right? Do you get a prize or
I was asking that. Is the
like what does it mean? How does that have anything to do with, anything really?
I don't know.
Okay.
Crying, yeah. Ooh, what should I see? Nobody's ever done it before, you see. Like there's nowhere you can look, right? Nobody has ever took an auto level up to the top of a mountain before. Do you know why?
Why is that?
Because it's an auto level.
It looks straight out.
You have to have a dude with a measuring rod. Now, where's he going to put the measuring rod? Oh, no, that's right. They don't need a measuring rod. They're repurposing an auto level for doing something that it's never been done for. That's why this is historic.
Well, if you can put a scale onto a photograph arbitrarily, why not be able to just look out, say, this is where the line is going to be, just be able to just draw a line on a photograph too.
Put a ruler on a photograph. Ranty's taught him that, I think. Ranty
Is
came
the
over with the optics.
is this tower supposed to rise up to the top of the mountain? Is that what they think's going to happen?
No, it's going to show the drop because the mountains 90 miles away in Chaiki's photograph are below the tower.
It's not Chaiki's photograph.
Well, the one he always pimps out.
He puts the line in the
Chaiki's
sky.
proof of the globe. His rock solid proof of the globe.
Have you seen it? I'll see if I can find it. It's really, really nice. Like
Literally, eye level is touching the clouds. Like
he brought it up like every single day for like a month and a half.
Yep. And then he just and then suddenly it just he just stopped. It's weird.
Yeah. Well, this is the one. In the live stream. That is a stunning photo.
Without the eye level in the clouds, just doesn't have the same effect.
Look, you can even see the little yellow bands on the windmills that are at the bottom of all the windmills. You can see it's stacked as well. Obviously, the windmills don't have that many blades.
Oh yeah. Just noticed that.
But still, like an amazing photo that. You can even see the double color on the Isle of Man in the background. Doesn't look like that all the time, but I mean, who was talking the other day? BioDual thinks it looks like that normal. He thinks that's a normal camera picture.
How much is that going for? I see it's a stock photo.
Yeah, Stephen Cheatley. He's done a few. He's done it. He did a really nice one of the
Anybody have the high res original photo? Anybody buy it? In other words, nope.
No, I've never bought that one. It's a nice one. Is it? Like he does say that he changes, you know, the focal lengths and everything that he uses. Makes it all look different, you know, because he's a professional photographer.
Is he on a mountain when he took that picture?
900 feet. He'd be like, not on a mountain, but he'll be around Winter Hill somewhere.
What's the elevation that Ranty's supposedly going to?
I think it's about something like 1,500. It's another like 500 feet higher than that one where he is there.
They were saying, I think, 1,100 feet, 1042 or something.
Like, I've been in the Rocky Mountains. I know what it's like to be on the tops of mountains and stuff. And if you're looking at something that's down in the ground, like oftentimes you got to look down a little bit, I guess, depending on the distance. But I'm not sure how an auto level is supposed to. It'd be interesting to see how that works because it looks straight out, right? If it can even see it, of course.
Yeah, it's only a 32 times scope, right?
Right.
You're not going to get any magnifiers or 300 mil lenses.
Is that the same photographer, the one with the moon?
I think so, yeah. I mean,
That's a nice one.
Yeah, but that's the effects of the lenses that he has on his cameras that sort of like they compress the image and bring the object in the background a lot closer than it would be.
Yep.
He does say that.
Yeah, that's a very cool one with the moon too.
Yeah.
He took that one as well.
Yeah. Trying to find the other one. I had another nice picture of him. He went over to the Isle of Man and took one back again. Wow, Aurora Borealis over Lancashire.
Well, I hope Ranty isn't expecting to get a view like that with a 33 times or whatever he has, 26 times auto level.
Yeah, Biodo thinks you get that every time you take a picture from around there. Because the normal camera, he thinks that's what you see.
Yeah.
So why would it disappear if you use a 32 times scope?
This guy's lens alone probably costs more than what any of us have for a camera on here. Just the lens.
You want to see his pictures, man. They're beautiful. Places he's been. His flicker. Yeah, man. Albums, let's see. He went over to the Isle of Man and took a picture back again of a night time. So you've got a picture of him looking one way and then a picture of him looking back of a night time. You can see Blackpool Tower and the mast of Winter Hill in the distance. So, the mountains up there again, and can't find it now though.
Ed, is that your drawing there? Are you displaying your drawing skills?
Yeah, Rakia thought he had some sort of argument by saying, "Oh, so a curve is a line." So I drew him a line.
Nice. I like that.
Yeah, it looks
Could've
good,
signed
doesn't it?
Could have signed it. you want to take it back? Sign it, and then you can.
You want me to sign it for you?
Yeah.
All right.
Yeah, you put that in the gallery. I mean, like, definitely.
Should turn that into an NFT and put it on crypto. Get them bidding on it.
Yeah, I leave that up to you guys. Here.
Title it "Align" by Ed.
How did he lie about me that time? Did he say something? I said something. A line was on Earth. Something about line in Earth.
He drew you a picture. We're getting
Yeah, I
him
thought.
to sign it for us.
It's almost like art.
Yeah. There you
What
go.
did he say
Look
about
at
Earth?
that.
Ed. What did you say that was about Earth and what I said?
Oh yeah, you thought you had some argument that curve.
Yeah, what was my argument
instead
again?
of curve, that somewhere it said line. So there you go. That's a line. Any problem?
What was my argument?
Well, if I read it from the
I'm
chat,
sorry,
you
what?
literally said 2 words. So line. Yep, there's a line.
Nice.
So
That's
line.
beautiful.
Yeah,
Beautiful, Ed.
I think so too.
You want to showcase that, and I've got just the place. Jose, he's the man. He'll see that. He could color it in for you with his crayons.
Yeah, just a little bit higher resolution, so I can print it and frame it. If you could do that, Ed, I'd
Put it in
appreciate
the
it.
gallery.
Yep.
That's what we need.
What the low resolution is the original art.
Oh, is that part of the artist, like the artistic effect?
Yes.
Like sort of Minecraft.
Absolutely.
Yeah.
For the record, I asked for a definition, their own definition of what is a curve. And then they started posting and drawing pictures of what a curved line is.
It's too hard to define.
Well, that was part
Don't
of
give
the.
them any.
That was part of the definition as an example.
No, it wasn't a part of my.
Use the word.
It wasn't a part of my question, though.
Yeah, but
I didn't ask
you understand that dictionaries often give an
Do you
example.
understand?
You understand?
that I never
Well, I
asked
wasn't finished
what a
talking.
curve-
Why are you clipping me?
Yeah, I never
Yeah, I
asked
wasn't
what a
finished.
curved
Stop
line
clipping me,
was.
Rikia.
You're lying
Please.
about me.
No, I'm not.
Yeah, you are.
No, because dictionary definitions often give an example how to use the word, how to use that definition in a sentence.
Congratulations.
So,
I never asked for a dictionary definition of a curved
irrelevant.
line.
You asked for a definition. There's the definition.
Irrelevant. I asked for your definition of a curve. Does that have anything to do with a dictionary definition of a curved line?
Does that mean people can't use dictionary definitions? They have to come up with their own thing? If that's the case, then why at all have dictionaries in the first place? You're not making any sense, Rikia.
Well,
if I
in
ask
essence,
you what is the definition of a dog, and you give me a definition of a cat.
Yeah, but that's not what's happening, though. There's definitions of curve from the dictionary.
So not your definition, one that you found in the dictionary.
People use definitions out of the dictionary, otherwise dictionaries would be useless.
Yeah, is that what you're doing?
Yeah, well, you know that's the case. Stop being a dumbass. Come on.
So that's what you're
This is
doing.
ridiculous.
You're giving a dictionary definition, not your personal.
Yeah, that's what people use. Dictionary definitions, yes.
Okay. Well, you're no help at all. He Googled it.
Why is
Hey,
it no help? Do you not use dictionaries ever?
Well, no, I can go look at a definition in the dictionary. Why would I need you?
I see. So you just want to make up your own definition and ignore the dictionary.
No, I wanted to hear your
Oh, well then where do you get your definitions from, Rikia? Do you just make them up yourself? Or do you get them from the dictionary? Which one is it?
No. I don't usually go to the dictionary for
Oh, so
definitions.
you
I
just make it up. Well, that
Yeah,
says a
just
lot
make it up.
about you.
You have no imagination. You couldn't make one up.
That doesn't matter.
Okay, good luck.
In other words, irrelevant.
Don't worry, Ed.
I
We've,
was
we've all been through it. It's hard work, and there's often quite a fight back and a pushback when you get asked a question like this. Challenging, isn't it?
No, it's not challenging when people
uh,
refuse to use dictionary definitions.
maybe it's
just
me though.
dumb.
But maybe it's just me the way I phrased it. Bev, why don't you ask him a question about curve?
How would you personally, Ed, define a curve?
I would use a dictionary. I don't personally
good.
define words because there's dictionaries that already define words. And that's what people use. So why should I make up my own definitions when nobody uses that?
Okay, so you wouldn't try and express it to somebody in a way that you think makes it more palatable.
Well, that's
right?
just my expression of the definition then.
Because you can't.
That's not the definition then, Bev. You're asking for my...
define... Yeah,
But
I believe it's
you're
very
asking
similar to
for
the
my
way
expression of the definition.
No, I was asking
That's
how would
something
you
different.
define.
Can we turn it around onto you, Bev? How would you define it?
Well, that'd be giving the secret away, wouldn't it? Because you have to use a straight line.
Well, a deviation from
What?
straight. Could that be one of the definitions or an attempt?
Well, it's not much of a definition, is it? How to actually define the curve, is it?
Yeah, correct. I'm saying it's not straight, so yeah, I'm saying but it's
Just
not.
let him answer it, not you.
You need to have a radius.
That's a straight line, isn't it?
Yeah,
I think
correct.
he asked about curve. So why are you mentioning straight line?
Because he's right.
It's right about what? Mentioning straight line when you're asked about a curve?
How you can define a curve, yeah.
Yeah, an arc.
You can define
I
a
mean,
curve
how do you get an
by
arc?
using straight lines.
Yep.
An
So
arc
you're trying to
The
define
only
something
way you
as to
can
what
do
it's
it.
not.
That's why you guys struggle, because you don't
But
like
you're
straight
trying to
lines.
define something as to what it's not.
No, 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 no.
That's the
Wait,
problem.
wait.
Yeah. That's what you're doing, Bev.
No. The
Yes.
truth of the matter is, it's undefinable. That's why you struggle with it. That's why everyone struggles with it. You can only define a curve with a straight line.
I mean,
Straight line,
if you're
equal
saying
distance from the center.
well, yeah, but that's not actually the definition. You're using a radius to express an arc, which is yeah. Again, I'm gonna struggle.
That's how you
But,
define a curve.
Well, that's struggle. That's why you shouldn't even say anything about it.
Yeah,
First
it's
of
not
all,
for you to do it, right?
What
do
are
it.
you using to define the radius? A straight line, right?
How about
Hey, Ed,
if we use
welcome
a
to Flat
circle
Earth.
to define curvature?
All messed up.
So postulate 3, Euclidean geometry, and that a circle may be described from any center at any distance from that center.
Mm. That was me thinking about it, honestly.
You literally describe it by where the center is and the distance from that center.
Which is a straight line.
Yeah. Because in geometry, all it is a point mover. A circle is an equidistant point mover. A circle can't really be defined. People will tell you they can.
Not without
That's why
using
you
words
use,
like infinite and perfect.
that's why you use a compass to draw a circle. A compass.
Yeah. I did rewrite all of the postulates for the ballers once, so let's see whether I can find that. Yeah, geometry's dead simple, but sort of teaches you logic.
Yeah, can I like segue? It's not so much. I mean, it's on the same topic, but you heard of the globe argument of having known distances, which only work on a globe since they're curved distances. You heard that like argument before?
So what does it
Like
matter?
flight paths.
Yeah.
Like you have, let's say, 5 points on the Earth, and the only way you can connect these lines is if they're curved with their known distances, because they're allegedly the shortest paths from one point to the other.
Yeah, that's assuming that in reality you actually go in a straight line.
Well,
Yes, exactly, George.
I
But
always say that you can't tell a distance, right? On land, you can measure it. But as soon as you hit water, you've got currents. As soon as you hit air, you've got, again, currents. How do you tell how far you're going when you're fighting against the water that's moving?
But just stick to the land then. Just focus on that then.
Oh, the Cove Show.
That can be mapped, right? The land is definitely mappable. But
I'd say
as
so.
soon as you hit the water or the air, how do you tell a distance?
I do it in a like different way. I ask, how do you know that path is straight? I mean, even when they say it, it's like a great circle path, which in essence is not straight. But I understand when they say it.
So can I ask you a question?
Oh, go ahead.
Well, I would
wait.
say no. You can't ask him a question.
No,
No, I would say no because he was talking. He was talking. You know, he was in the middle of a thought, and you jump in. Like, are you gonna sidetrack the
I'm not
conversation or
sidetracking the
what?
conversation, but if you're gonna bring up a baller argument and we're talking about something that can be definitive, why are we even talking about that? Let's talk about what we can prove. I don't care about that
That's
argument.
fine. That's fine. I
Okay,
do
well
care
then,
about
yeah.
the
Well,
argument because
just take it back.
Okay, go ahead.
Yeah, I mean, it's something we actually get into and we talk about and we have a back and forth. So I do
You and
care.
who?
Yeah.
Me and the
Go
ballers.
ahead. Go ahead. If you have proof, go ahead and present it. We'll talk about it.
Yeah, I was more asking a question because I try to tackle. For me, I think about it from my point of view, and my questions are things like, how do you establish A to B is actually a straight path, right? Because even if we're going to apply their logic within their statement that path is the shortest path, my question would be, what is the method they're actually establishing that? And I never get a, no pun intended, straight answer to that question. But it's interesting to hear others' thoughts about it. That's what I was trying to do. But if
I mean,
we want to move on, then it's fine.
If you're talking about it, let's say the shore of in France, to where is that? Czechoslovakia, right? Like if you're going like over Europe, where people have been for a long time, and if there's a distance that's said to be from one end to the other end, and nobody has come forward and said they have a shorter distance than that, wouldn't that be enough that it's been claimed to be the shortest distance like the distance that's stated is the shortest possible distance between those two places. Otherwise, somebody would come forward with, an even shorter distance, and might be able to prove it.
Let me just kind of elaborate. See, you know how, let's say, on a AE map, not that I'm saying I subscribe to, but the idea of it.
I gotta go.
That's fine.
Yeah, thanks for telling us.
But yeah, see, in traditional navigation, we use things like compasses, right? And you get a heading. Say you travel east. That line of east on a AE projection would be a curved line, right? And let's say on a distance that's like 1,000 miles, when you're using a plane, for example, and you're taking that heading, how do you know? Like on a globe, you think it's a straight line. But what if it's actually curved? Like, how would you tell the difference?
It'd be curved it'd be curved on the globe as well. Only on the equator it would be a straight line, but if you go eastward on a globe anywhere else, the entire time following east, and it'd be a curved line.
Come on,
Well,
east
yeah.
west's a curve on both of your maps, isn't it?
Yeah. Actually, that's correct. Yeah.
But when you look at it, everybody knows east, west, north, and south, they're perpendicular. It's a paradox, isn't it? Like,
No.
is it curved or is it straight?
They're curved lines, but you're right, they are perpendicular. Yeah, the lines of the
cannot be both.
Yeah, but the lines of latitude are curved. The lines of longitude are all straight, and they're perpendicular to one another.
They can't be.
I mean, I don't see why you say that.
Because they can't be both curved and perpendicular. Because perpendicular is two straight lines.
If you stack flat
they
plates,
can't be curved as well.
Stack flat planes above one another, and all those planes are parallel, and you have straight lines cutting through all those flat planes, they would be perpendicular to one another, and those flat plates could be curved around, which they are.
I just want to point out that
how can they be flat and curved?
A plate is flat and curved. That's what I'm saying. It's a plate. It's like a circular
flat
plane.
And curved, Kosho.
Yeah, just like a plate. Yeah, they're circular. They're circular planes.
Okay,
all the different lines
but
of latitude.
No, Kosho, you're conflating the surface of the plate and the circumference. The circumference is curved. The surface is not.
Yeah, exactly. That's what I'm saying. They're stacked plates. Like those plates are stacked, but in reality, the lines of latitude aren't. We don't cut the Earth and stack them. But if you're viewing the Earth from outside view, that's what the lines of latitude. They would be, north to south plates stacked, and then the lines of longitude would be these great circles that go, all the way around.
No.
Did you say straight circles?
Great circles.
Straight circles.
I said great circles. They'd be straight lines going around the poles from pole to pole.
Not straight though. They're circles.
Well, they're straight on the surface of the Earth.
Yeah,
They're not straight.
They are greatly
circles.
straight. They are greatly straight circles or straight great circles. Yeah. That's what he's trying to get away.
But you realize if you're following a path on a circle, that's not straight in any way, shape, or form, right?
Well, yeah, in non-Euclidean geometry, there's no actual straight lines, but the analogy to the straight line is the geodesic, or the great circle, meaning it's the shortest path between 2 points. And along the surface, you'd be going in a straight path, but you're right, it'd make a great circle, which is what's called a great circle.
So, do you know of any 2D surfaces of Earth in my area I can go visit?
Sure. Yeah. I mean, every surface you come across is 2D by definition.
So where I'm standing right now is 2D.
If you're talking about the surface, yeah.
Yeah, I'm standing on the surface. Like I'm not in the air. I'm on the ground.
There you go.
But that's 2D.
All surfaces are defined as 2D.
So where I'm standing is 2D.
The surface of where you're standing, yeah. Just like if the wall, you could be touching the wall. The wall's obviously 3D, but if you're talking about the surface, the surface is 2D.
I can stand on a 2D surface.
Sure.
I can touch it.
Yeah. You paint it, you can define it, yeah.
Can think about it.
Think about it.
But I can see it though, right?
See it, you can hang out with it, buy it popcorn.
So where you're standing right now is at a different elevation, probably a different type of surface, right? Texture wise, but it's still a 2D place.
Well, no, the surface is 2D. If you're talking about like it depends on how you're going to talk about it. You're talking about the actual location.
Yeah, that's what I said. Where you and I could go.
My location in space and my location on the surface, you're describing it 2 different ways. So the location in space, you're talking about 3D
I only
position.
described it one way.
Yeah, if you're talking about your location on the surface, then you're talking about the Earth in 2D surface.
I'm talking about where my feet are.
All right, let me ask a question based on where you're going, Rocky. Kosho, if I'm standing in one location and you're 3 meters lower than I am, but we're standing on the same surface area, does that change your answer? Are you standing in a 2D location and I'm standing in a 2D location, but you are lower than I am?
No, if you ask for information, we're not standing on 2D locations. We're standing on the locations are in 3D space, unless you're describing the location on the surface. If you're saying your location on the surface, then it's a 2D that you're talking about.
Okay. Let me try to, maybe since that didn't work. If you're standing in a location and your right foot is higher than your left foot, is where you're standing a 2D surface?
All surfaces are defined as 2D. Doesn't matter.
So is
how
that
you
a
describe
yes? Is that a yes?
Yeah, if you're describing the surface, the answer is yes.
Well, can you, Kosho, agree with you can mathematically express it? Yeah, like the idea of topology, right? But when you say it's defined as, that's kind of a slippery slope.
Not really. In topology,
I mean,
the surface is always going to be 2D.
Yeah,
but if
exactly.
If you're describing your position in space, obviously there's 3 dimensions in space. So
okay,
yeah,
so
all you're doing then is just taking an expression of Euclidean geometry into expressing that in a 2D surface of that, correct? And you're saying that's
So anytime a surface is being discussed, there's only ever going to be 2 dimensions. So it's always described in 2 dimensions.
Okay.
Why? Because it's not.
That's what a surface is.
Yeah, but if you look in live stream right now, right, you keep saying it's defined as that, but would you say that definition defines 2D or 3D?
No, that defines that defines a 3D structure, and that's a 2D component of it. This is that's what bounds a solid.
It is a superficies, the surface.
Okay. Right.
It just says the solid is 3-dimensional, right?
Yeah, the solid is, yeah.
Right. So that which bounds it would be the surface.
That's right.
So that surface must be 3D too, right? If the object is 3D, then the surface is also 3D because it is that which bounds the solid. Definitionally, that is the definition. The
definition is 2-dimensional.
Yeah, you're stuck in 2-dimensional plane geometry.
It's a 3-dimensional object.
The redefinition.
It's a three-dimensional object in the surface.
Can I just quickly just say, yeah, it's just a way of mathematically expressing that 3D surface in 2D. That's what I'm trying to allude to.
The object, yeah, exactly. The object is 3D. The object is three-dimensional. The surface, which is a component of the object, the surface of the object is in 2 dimensions. This is how. This is even what.
Well,
2D
it's not,
thinking, dude. Come into 3D. Come into reality.
Bounding, going to the definition Bev posted. If something is bounding a 3D surface, then in and of itself, it must be 3D because it's following the contours of a 3D object, right? There is that that depth factor that you have to consider. You can express it and show it in 2D mathematically. And that's what I'm alluding to. I mean, you can express it in that way, but in actuality, in reality, it is 3D.
But that's a component.
If you're
That's
not
an
leaving the
attribute.
surface, where is the third dimension come in?
No, that attribute you just said, depth, is not an attribute of surfaces. Surfaces don't have
I know
depth.
it's not. I know, but
Right,
it's
that's what I'm saying,
bounding. Well, just listen closely to what I'm saying. Like I tried to put it in simplest forms, but let's take a cube for example, right? A cube has how many sides?
6 sides.
Okay, are these sides all on the same plane?
No.
Well, yeah, that's what I'm saying.
That's why the cube is three-dimensional. But each of those each coordinate on the surface of the cube is either going to be 2 dimensions. The surface is two-dimensional.
Here's the problem. What's the smallest dimension of your surface plane? Like, what is the smallest conceivable thickness for it to be rendered in logical reality? It would be an atom, right? And if you're going to go down to the atom has a thickness. Therefore, your 2-dimensional surface you're trying to evoke has a depth. Thank you.
The surfaces, as it was agreed by Egypt, don't have depth. Okay, when you're painting something, and you need to know the surface. You need to know this. Hold on. You need to know the surface area when you're talking about the surface of something. The surface area is in 2 dimensions. That's why it's
even when you're
square
painting
miles,
something
square feet.
on a piece of paper, there's a 3rd dimension to that surface, i.e., the thickness of that paint. Now,
in reality, it's in 3 dimensions, but the surface is in 2.
Yeah.
Well, you're missing
Length
the
and
point.
breadth.
You're missing the point. In order to have a surface, you have to have dimensionality in depth. Otherwise, you don't have a surface, only a conceivable
Incorrect.
one rendered in, only rendered in virtual reality. That's it. That's the only way you can have a surface in 2 dimension. Because the second it's rendered in the 3rd dimension, i.e. reality, it axiomatically has depth to it, no matter how minute the surface is.
The volume.
Well,
even if it's down to the atom.
I'm reading the definition right now. It says surface, geometry, a continuous set of points that has length and breadth, but no thickness. No thickness at all.
Yeah, that's theoretical.
You're talking theoretical geometry.
No,
Okay,
physical.
but when you get into reality, there has to be depth to anything for it to even exist. The only way that you
Any
can have
physical
something.
object has thickness.
Yeah, the object
the only
does.
way-
That's right. The object does.
Yes,
Yeah,
the object
surface.
The
is a
surface.
physical
The surface
thing.
is
Has
not. The
thickness.
surface is an attribute of the object.
Exactly.
Yeah,
Therefore,
just
it
in
has depth.
engineering
An
or
abstract-
theoretical term.
Yeah, it's an abstract or a concept of trying to mathematically represent
Yeah.
that, again, surface. That surface
So you can draw
in
it on
reality does not exist in of itself.
Yeah, you can't show me a
You're
single
trying to
object.
express that mathematically and
Exactly.
conceptually. You're trying to show me or find a location. Let's say, well, yeah, the application of it mathematically is trying to find express a location on that quote unquote surface, right? And I think we agree. It's just the disconnect of.
I gave an example the other day that made sense to me. Let me see if it makes sense to y'all. If I plot a point that is at the center of a building, is that point at the basement, the roof, or above the roof of that building? Right? It's either one. It's just a point.
The only way.
The center of the building, though, is not going to be describing anything
The,
on the surface.
the only way that you can have a 2D surface in reality is if it's not consistent of a medium, or if it's not consistent of a medium, like with mass. And the only way you can have that is with a field, i.e. like a magnetic field per se. At the outskirts of that magnetic field where it falls off, there's nothing. So your surface only resides within the field itself. And you could consider that surface at some point, I guess, to be two-dimensional to a degree, but it's really three-dimensional, being that we are three-dimensional beings living in a three-dimensional world. You can't overlay 2D with 3D. They're two separate realities, two separate paradigms. They don't intertangle, only conceptually.
No, okay, so here's another definition. Surface, in geometry, a two-dimensional collection of points, flat surface. A three-dimensional collection of points whose cross-section is a curved surface, or the boundary of any three-dimensional solid. So it's the boundary of a three-dimensional solid, but it's a two-dimensional coordinates on it.
So it does say it's 3D then, right?
Well, it says a three-dimensional collection of points. Oh, no, sorry. It says
That's it. Yeah,
whose
don't read it,
cross-section is
just
a
post it
curve.
so we can read it with you.
This is from Scientific. This is from Britannica. But yeah, when you're talking about a sphere, the three coordinates on a sphere are the two angles and the one radius. But if it's a sphere, then that radius never changes. It becomes redundant.
So,
did you say 3D coordinates?
I'm posting it.
Yeah.
No, it says a flat surface,
3D.
a three-dimensional collection of points whose cross-section is a curve.
So that's 3. Then we are saying that the curved surface is three-dimensional, then, right?
Well, no, as I told you, like with the sphere, that third coordinate is the radial distance, which is consistent.
Yeah, which is the third, right?
Yeah, it's how you would describe it. It's how you translate it from
Three.
three-dimensional space to the two dimensions that it's defined in.
Described. It's not defined. It's described. You have to have reality to have an actual explanation or a definition thereof. But what you have is a description of a concept.
It's never been Kosho's strong point.
I mean, this thing I'm posting says it says it exactly again. It says surface is continuous boundary dividing a three-dimensional space into two regions.
I'm trying to point out something. So, Kosho, let me ask you a question. Where you stand at? Is that 3D?
Okay, let me explain this to everybody who doesn't get this. And whoever doesn't get it afterwards, just look it up because this is going to be perfectly clear. Objects and positions in our world are three-dimensional coordinates. Okay. When describing an object and describing the surface on that object, it's described in two dimensions. That doesn't mean that we live in a two-dimensional world. That just means that the surface is a two-dimensional attribute of a three-dimensional object.
Cool. So where you stand upon, is it 3D or 2D?
I've just answered that. And I feel like if you're asking that again, then you're not listening to what I'm saying.
Yeah, it's 3D.
The position that you are at, the positions are in three dimensions.
Yeah.
If you're describing the position, if you're describing a position along a surface, then that position is in two dimensions because you're talking about the position on a surface. But if you're not describing the position on the surface, you're describing the position in space, then it's three dimensions.
Yeah, guys, hold on. Just this is deja vu all over again. I mean, we're in the end. I think we're agreeing, but there's a little disconnect that I don't think anyone's
referee here. Come on.
No, I think we agree. I mean, it's just.
No, I don't agree.
We're never going to agree, right? That's the point.
I can give you this. The point that I stand on in my grass, the surface that I stand upon, it's not 3D because I can keep on digging. I'm still finding more stuff up under my feet.
There's your third dimension. Your depth gives you your third dimension.
Yeah.
Well, what Kosho's saying is, he's talking about strictly the surface, and That's just a concept, right?
Yeah, it's a
not.
concept. We know that. That's why I
Yeah,
wanted
it's a
him to say
convention.
what he's
It's
standing for.
yeah, it's a mathematical way of expressing that quote unquote
That's
surface.
what we've been saying the whole time.
Yeah,
They
yeah.
disagree
And
with
that's
that.
why I feel like Kosho's kind of agreeing, but yet he's kind of trying to.
He's not.
He is kind of
I'm using.
reifying that.
I'm using. No, I'm not
that
reifying
concept.
it. The word that we're talking about is a word that's used, and we're talking about geometrically. Okay, and geometry is math, so it's fine to call it a mathematical term. But in math, the surface is described in 2 dimensions. If we're talking about it colloquially, that's
Kosho.
fine. But in math,
solid
surfaces are
geometry,
2D.
it gets redefined.
No, that is solid. That is solid geometry. Solid geometry is where surfaces are.
In
3
3
5 hours is
dimensions,
long
they
enough,
are
guys.
Kosho, man,
rounding.
what?
5
This is
hours is long
ridiculous.
enough.
Canal Kosho.
Bring a piece of 2D surface of Earth. Just bring it to me. Put
Exactly.
it in a
Give me an
box.
example.
Yeah.
Why don't you guys do this?
That's
Why don't you
all.
post a definition describing it
Why
the way
don't
that
you
you're
do
saying
what I
it,
just
and I'll
asked?
continue to post definitions that
Who cares
say it
about
the way I'm saying it.
definitions?
Well,
We care
that's what
about
we're talking about.
reality.
We're
We
about how
don't
these
care
words
what.
are used, what they
No,
mean.
no. We're saying in reality, bring me a piece of
So
2D surface
this is
of
why I
Earth.
said what I said a
Can you
second
do
ago.
that? No,
This is why I
no,
said what
you
I said a
can't.
second ago, because
I
you
know you
guys
can
still
say
don't
words
get
all
it.
you want.
So no, yeah,
It's
no.
called
So try
sophistry.
listening instead of asking the same question.
Do you
What I
get
said
what I'm
was
asking?
the
Did you
objects.
listen
Yes,
to me?
I do understand what you're asking.
You're
You're asking a
obfuscating,
We
question.
heard you.
You're asking a
You're
question that says.
We
You're
heard
asking a
you.
question that says you didn't know
You're
you didn't hear
dancing
me.
around.
You
You're
didn't hear
dancing
me,
around the
Rakia.
facts.
Because I
You're
told
dancing
you,
around the facts,
dude,
Coach.
shut the
We've
fuck
asked
up.
this over an
Shut.
hour
It doesn't
ago.
do. Just
Let's
I
calm
asked you.
down.
Listen to you.
respond to
Everybody
Rakia.
just
Maybe
dial
you
it
should be
back.
quiet, Coach.
Wow, here we go.
Everybody just dial it
Responding,
back. We go
responding to
one at a
Rakia.
time.
Triggered.
You're taking us in a circle.
I'm responding to
You're
Rakia.
not
Please
talking
just
to
sit down
me.
for a second.
You did not
Yeah,
respond.
Rakia.
You did not answer my
Rakia,
question.
I'm
You are
trying
not
to, dude.
responding to me.
Yes, I
So
am. I'm
will
talking
you
to
shut
you,
up?
Rakia, and
Will
I'm
you
saying
shut
words.
up?
That's me responding to
Okay,
you.
then shut up. Can
Yeah,
you shut
be
up?
quiet, Kosho.
Can you be quiet, Kosho?
You
Okay.
just asked me, can I bring you a
Kosho,
2D
please.
surface of the Earth? That's
Oh
what you just
boy.
asked me. Can I answer
So
that
you
question?
can't be quiet. So you can't be quiet? Because I'm
You're
going to ask
asking
it
that
one
question
more
again, or can I
time.
answer that question?
So you can't be quiet. This is you getting triggered, right?
I'm just trying to answer the question you asked, man.
Yeah, this is you getting triggered, right? I just asked you a question.
Okay, I won't answer it. That's fine.
Yes, it is.
Okay, that's
this
fine.
is how Kosho gets when he gets triggered.
Does anyone
I'm just
else
trying
want
to
to
answer the
answer my question? Kosho, we're fine with you going on mute. Just go on mute. I'll ask someone else.
I mean, I don't have to answer the question, but there's no need to go on
Right,
mute.
you don't.
But I
So
thought
go
the
on
next
mute.
time you don't want me to answer,
I
just
can
don't
ask
me.
it right to someone else, right, Kosho? I mean, I don't want to put you on mute so I can ask someone else, but I will.
Just ask your question.
Is there anyone else here, right, that can bring me a 2D piece of the surface of the Earth?
I
Just
asked
one
this
little
to
small
Ed.
section.
I asked that same question already an hour ago, and they sat there with crickets and did
No,
nothing, and
absolutely
then
not.
wanted
That's
to.
a lie.
You
Don't
should
lie
stop
about me.
asking
bring
them
me-
for
bring me
things they
2D.
can't give you.
You're lying.
Just
You can't
turn
give
to
me
the
2D.
Just
Does
look
anyone-
at the ground.
Ed, is that your answer? We can look at it, define it, talk about it, but you can't bring me any of it?
Yeah, I told you, look
Physically?
at the ground. There it is.
Yeah, I
No,
could scratch
I didn't
that.
ask what I can look at. I said, can you bring me a piece of it so I can hold it?
Well, I can scoop out some dirt, but then the surface of Earth would just increase.
So is that yes, you can bring me, or no, you can't bring me a piece of that 2D? 2D. So if you bring me dirt, that's not 2D, right?
It still has a surface.
What if you bring me theoretically, right? In
No,
concept.
in reality, it still has a surface.
That's not two-dimensional, Ed. We're asking for 2D,
But
not
in
surface.
reality, it still has a surface.
I think I've
though.
made.
We're
I think
asking
I've
for
made my
2D.
point.
Yep.
This is
For
what
sure.
we get with these guys. They can't hold to anything.
Yeah, I
That's
just did.
that's why I said what I said. You know, where you stand upon, if you dig up under it, damn it, you get 3D, not 2D.
The second you
But the
scratch the
surface is
surface,
2D.
the second you scratch that surface, you no longer have 2D. The second you hand me that surface, you no longer have 2D. The second you are physically in 3D, right? It's a concept. You have to be within 2D at all times for it to be a 2D surface, and we're not in 2D, my friend.
No,
Welcome to reality.
everything has a surface though, so it's still 2D.
Yeah, that's nice.
It sure is.
Cool story, bud.
No, it's not a story. That's just how reality works.
That's
Sorry
how
if you're mad
exactly
about it.
That's how
a
concept works, bud.
reification. Yeah, a reification
Why does
fallacy
this sound
works.
like science for
No,
Let's get off this
not.
topic. Let's get off this
Let's
topic. It's been
yeah.
5 hours.
Okay, bring up another one.
Okay,
I'm
Freemasons.
fine with- All right.
Are they as
Freemasons
bad
are
as?
2D.
Are they? Come on.
Well, get specific. Make a argument.
Okay. Who gives Freemasons their orders, or are they self-operational? I have no clue.
That's
I
a
expect that they
question.
get orders from above.
It's so boring.
Not an argument.
Yeah.
Make
Nothing
a
This
is
statement.
isn't.
between
Tell us
every
something
This
that
isn't an.
maybe we can
This
try
isn't
to
an
dispute.
argumentation server. This is a server for sharing and conversing.
Sharing
This
what?
isn't a debate.
For
Go to
Are you in a
Freemasons if you
Freemasons,
want to debate
bro?
something.
Are you
I
in a
went into their
Freemasons?
lodge once and asked them some questions, but I never joined. Just had one
So did you get
one
your
afternoon's
answers?
conversation. No. They seem like liars.
Okay. Well, don't know nothing about
It'd be
that.
cool if y'all don't want to answer his questions, just don't. But I mean, he has the right to ask. Someone wants to bring up something else, go ahead. But
okay, they get their orders from within. Are we done then?
Yeah, go ahead. Bring something else up. I'm just sick of this monkey business with 2D, 3D surface bullshit. It's simple. Anyone who spends 5 hours talking about it,
Yeah, so
I think we all agree with
let's
that.
not go over it again then. Just change
Good
the
idea.
topic. Because
I
you're
did.
you're trying to circle it back to
Done.
that bullshit.
Done.
So
Well, because
just talk about
part of the
something else.
problem
Then.
is part of the
Done.
problem is anytime you guys get challenged, right, and you can't just answer yes or no. This is what you do. You turn to let's just change the subject real quick. So
Now,
again, real quick, Ed,
multiple people wanted to change the subject,
just
so
say yes
just
or no then.
change it.
Just say yes or
No,
no then.
don't return back to the same topic, Dicelo.
All right, just
We're
give
done
it
yeah,
yes
with
or
that.
we
no.
heard you.
Okay.
We heard you, Ed. Thanks.
How
Can you
about
hand me a piece of 2D surface, Ed?
Can you shut up, Dicelo?
That's
let's
really
do
not
a,
what
like
I'm
a
hearing.
kind of mix of both, like a mix of the whole globe thing argument or heliocentrism with some spirituality. Now, does
Someone say
you guys
something.
think
Just someone say something.
yeah,
Yeah, go ahead.
heliocentrism, does that need to nihilism? Do you think, guys?
Does it lead towards nihilism?
Yeah.
Why should it?
Oh, what do you mean by
Well,
nihilism? What do you mean by nihilism then? Just define that real quick.
Nihilism.
Whatever.
the idea-
Nihilism, nihilism.
Yeah.
The
that
belief in
nothing.
no objective meaning?
Yeah, nothing means nothing. Like nothing has real purpose or meaning to it, right? Like the
You do know
mindset
that
of
not every religious person is a flat earther, right?
Nice surprise.
yeah, I realize that, but
Right.
I'm opening a question.
Right. Well,
for
yeah.
everybody.
Okay.
And likewise, you could say not every heliocentrist is an atheist.
Or a nihilist. So
Correct.
whenever,
But-
whenever
but-
you have, right? I understand your question, but I'm going to answer it in the sense that there is always cross pollination with worldviews. That is that you're not going to always be consistent with the worldview that you hold. So even a heliocentrist, might find meaning in his life, but I would argue that he's finding that meaning in another philosophy or worldview that's not.
I would agree with all of that, but the problem is can that be done logically and rationally?
Right.
Like
that goes back to, from my background with Christian philosophy, presuppositionalism, right? Their argument against atheists is that an atheist in order to deny the existence of God, has to climb up on God's lap and spit in his face. Right? So he has to already assume certain realities to be true, but he doesn't have justification for those realities. He has to go to another philosophy, borrow from it, come back to his world, and start playing with it.
That's because ontology isn't objective. Like there's no like when it comes to spirituality, like it's really subjective in a lot of ways. Once you start stepping into like the metaphysics.
So, I mean, I guess the thing would be we would have to have someone here make a claim that life is 100% meaningless. You know,
Well,
we would have
what
to
it is. It's called disobjectification, and
Okay,
that's something.
are you a disobjectificationist?
Well, I tried to be. I tried to like assert myself with the best logic and rationale I can, and without diving off into beliefs, right?
Okay,
Right.
so what does disobjectification mean?
I mean, you could call it theurgy. I mean, there's many ways to put it.
Okay, what does that mean? All you're doing is giving me a different term. I'm just going to ask you to keep, because I don't know. I'm asking you honestly. So please, instead of giving me another term, just define disobjectification.
Disassociation with the object being the sole root of one's existence.
I don't know what that means.
Well,
it means that some people think that consciousness is an emergent phenomena, and they think that their consciousness is created by their body's operations.
Okay, so now let's go back to the other guy. Is that what you meant by disobjectification?
No, that's the opposite. That's the opposite what I said. Some people.
Okay, so okay, great. So I don't want to be rude, but I want to have a conversation with this other guy who used the term.
Yeah.
He was the guy that I asked the question.
Yeah,
cool.
I think Fundy did a good job of touching on it.
Okay, because I thought I asked you if that's what you meant, and you said no.
Well, it's essentially identity of self as other, which begets suffering.
Identity of self as other, which begets suffering.
Yeah, it's kind of like when you like watch a sad movie and you start associating with the character. You've now just digressed into objectification, and disobjectification is the separation of that.
Okay, so what you're basically saying to me is that you basically live your life as a sociopath.
Oh, okay.
Well, what that means, right? Because a psychopath has.
I think you're in the wrong place, man. I think you're in the wrong room. Talking to Dicel like that.
Listen, I'm just trying to. I'm coming across this information for the first time.
We heard you. We heard you.
I'm not done. Okay, wait a minute. Hold on, bro. A psychopath is someone who disassociates himself from other people so that he has no connections, right? The reason why he can slit your throat and not care about it is because he has disobjectified you.
Isn't that a sociopath?
Okay, so when this guy tells me that he is a disobjectificationist, I'm just saying, to me, that sounds like a sociopath.
Well, I want to touch on what you said. He can kill them because he's disobjectified, but I think what a sociopath or psychopath would really do to murder someone and feel nothing would be to objectify them, not disobjectify them, to not consider the soul that's within them and the life they're going to have, but treat them just like a plate that you can throw on the floor and say, "Opa, I give a fuck about it being destroyed." That's objectifying someone's life, not disobjectifying.
But basically, what I was trying to tell you is like disobjectification is essentially the liberation from becoming what is rightly the ending of false identity, which begins in understanding of wisdom and rejection of all false identity, whether it be material or noetic in nature.
All right, Dicelo,
This
what
is-
page
this
of the
is-
PDF is
Listen,
this?
Ed, shut up. Ed, shut up, Ed. He was just talking, and I was listening, and now you just fucking jumped in and messed up everything.
Yeah, it's just essentially the apophatism which breeds theurgy. It's self-purity or actualization, and the fulfillment of wisdom's goal being the self soul for wisdom, and the self and the soul are one thing essentially, not two. So existence inclines being towards non-self, and wisdom is self inclines towards self. And what is potential is not actual, though one is ever the soul or self. It's this actualization is liberation in itself. It's the transcendence, and it's what's to be actualized. And
I feel
is,
like
is
I'm,
meant by the complete end of agnosis, which is identity.
Yeah, I
is another which begets suffering.
okay, I feel like,
I'm sure,
oh my
but
God, you just keep talking, bro.
yeah, well, I'm trying to explain myself before you try to paint me with the psychopath brush.
Yeah, everything that you just said, I feel like I'm talking to Pete Shea. I have no idea what you just said. None.
I followed.
Have you ever
I'm
taken
a
a
pretty good
psychology
Dicelo
class?
translator.
You ever taken a psychology class at all?
He was reading from page 33 of the Ken Wheeler PDF. Ontology Primer, it's titled.
What would you
Page
like to talk
33.
about, Ed?
I have it right here in front of me. I looked up the sentence he just said, and it's right there. The whole thing, he just read it from the PDF.
What would you like to talk about?
Well,
You should get a better look at it. Go ahead and paste it.
Maybe something else than Ken Wheeler.
Actually, funny.
Oh, should we go back to 2D, Ed? 2D things that you can't hand me that you say exist? Oh, okay, that part.
Or it's just funny because remember we had a pleasant conversation yesterday or whatever, and we never got to finish.
Oh, yeah.
I don't know if you remember, because we got into other stuff, but we were supposed to follow up on it.
Yeah,
we could do it now. Okay.
If you wanna.
Well, I mean, it's quick. 'Cause I set everything up yesterday, and I couldn't share my screen at the time, so I ended up just making videos of it anyway. So I'm loading up my phone up. But you remember what I asked you about the longest distance that you trust or whatever that is correct on Google Maps? You said you could say that San Diego to Maine is correct because you've driven it.
Yeah, seemed pretty correct.
Okay. And I'm just going off my memory, but I think when I looked it up, it showed that it was about 4,400 miles or something like that, 4,410 maybe. Okay, so I'm going to post this real quick. Hold on. Because I've been asking people that, but with reason, so I'll show you. So basically what I did was I went on an app that's called the GADIP3. It gives you your XYZ coordinates instead of your spherical longitude and latitude coordinates. Because that's the way GPS gets it in its raw data. In its raw form, it gets it in XYZ. So I'm going to post those positions plotted in XYZ. Give me 1 second. Here we go. I did, like I said, I did San Diego, and I did, what city? I did some city in Maine, but I'm not sure if, do you live in Maine?
No, I don't. But Maine was the example. I clarify that I drove from Chicago to LA.
Oh, okay, I see.
But very similar. It's just another like 5 hours or whatever.
Okay. You mean, would you still be okay with that distance then?
Yeah, of course.
That's the one that I mapped, so.
And you're getting to why it matters? You got
right. Yeah. Let me post it real
build on
quick.
it.
Yeah, here we go. Here we go. 1 second.
Is this the Kosho show?
No, I'm just asking him a question, showing some to him.
I feel like you're dragging us down another 5-hour tour of nothingness.
You're a little unprepared.
But maybe why don't you live up to your name and do us all a favor? But yeah. So this is the two locations plotted.
Cool.
Well, I don't think what he did was cool. But regardless,
Typical Glober thing to say.
sure. I mean, you could just let us.
I could just
go
drown
for a second,
myself.
but,
I could just kill myself. Yeah. That's all you guys ever have.
That's not what I said. But regardless, yeah. So I plotted these points, and then they ended up in that position. These two positions, San Diego, and the other one was Caribou, Maine. And then all I did was I attached them to that origin point that they seem to be around, and it made that arc. And
I mean, you can't even differentiate 2D from 3D. Like, why are you even talking right now, bud?
I was just thinking the same thing, man. I was wondering
Yeah,
why
it's
you were
pretty
talking
scary,
in the
bud.
middle of me saying something to Fundy, because I'm almost done.
I mean, it's a big
but
waste
yeah,
of our time at this point.
well,
Let someone
you
else
could
to
do
have
us a
the
favor.
talk, guys.
But yeah, but
Just sit back and let someone else talk, man, because you're literally just killing the crowd.
I'm in the middle of saying something to Fundy, so I'm almost there. But yeah, Fundy. So I used the center point, the origin, and it made an arc when it connected those two places. And what happened when it did that was it gave me that 4,400 kilometer distance. So I'd done this with
That's
a few
an
other
issue.
people.
That's
It's
an issue, though.
What is that?
Because roads in America aren't straight lines.
Well, this isn't following the roads. This is following the shortest distance path. So, like, if you use like Google Maps, you just plot 2 points.
not what I did.
It'll draw
but how
a
did you,
straight line
right?
distance.
But how did right? Okay, listen. How did you get the distance? Did you travel along a road?
No. Google Maps just uses the actual locations. It
Okay, Kosho, listen very carefully. If you don't know, like if you're going to map out Chicago to LA for the first time, in order to create a program called Google Maps to enter in values of that distance, how are you going to get those? Are you going to travel in a straight fucking line the whole way? No mountains,
Well,
nothing.
they use
straight line.
They use data from planes to get the full maps.
Yeah. So again, so are you telling me that those planes have no deviation, 0 deviation?
Well, it doesn't take the speed and all that stuff from the plane. It takes the position
Yes
that's
or no?
plotted on the ground.
Are you answering the question?
It doesn't use
Is
the
it
plane.
yes or no?
It doesn't use the plane to get the distance.
Yes or no?
It gathers the data from the plane, but it doesn't use the plane's. It doesn't use the plane's
miles
speed.
per gallon,
No, they
Kosho.
don't. No, they don't.
MPG, buddy.
They use the planes to take pictures of the Earth. That's all they do. They're not using the plane's speed to actually figure out what the distances are.
Oh, you're so utterly confused.
I mean, that's just a fact. That's what they collect all the data and they
Did you
collect
get that
together.
from Britannica?
Not with the planes data, just with the pictures.
Did Britannica say that?
Okay, hold on. Kosho? Can you hear me?
Go ahead. Yeah.
Okay, all right. Let's say you're going to fly a plane over the Rocky Mountains and they're going to do a radar ping off the ground all the way across. So you've got elevation that's just zigzag, up and down, boom, 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 high, low, high, low, high, low, high, low. Are you telling me that they're going to turn that into a straight line to get the actual distance? How are they going to figure out?
Don't forget about the pressure differences, i.e., turbulence.
They don't
get,
use
like,
this for the
high-low
distances.
pockets of air where the plane will actually drop out of the air.
Yeah, they're not using this for the distances. You can use you can use things like the Haversing function.
Okay,
Haversing
listen.
function will give you the distance between 2 points.
Where do they get the distance from? Where do they get that value from?
They have the locations. They have the longitude latitude locations.
How did
for
they
any two
get?
places.
Okay, just because you know the location from, I know where this point is and this point is in my head. I know. Okay, there's a Chicago, there's an Illinois. Okay, whatever. Okay, again, you're skirting around of where they get the distance from.
I just answered it to you. You just
No,
wouldn't
you
listen because
didn't.
you talked over me. I said the Haversing function will give you the distance between 2 coordinates.
Where does
That's the function that they use.
Where does the Haversing function get its value?
That's how the coordinates are related to each other.
Okay,
so
that's not a value.
The coordinates have relationship to each other, and when you want to know the distance between 2 of them, you use the Haversing function.
Again, listen, in order for me to create a model using a different language, which is the Haversing whatever fuck, okay? In order for me to put my distance into that language, I have to have an original value.
Yeah. So
Where did that?
the
Where
coordinates,
did?
I'm telling you, the coordinates, the longitude and latitude, those are two angles. Those are spherical coordinates. And when they have those two coordinates, they know how to translate them to one another, how to find the shortest distance between two coordinates, for example. And you use the Haversine function to
What's
do
the
that.
shortest distance over the Rocky Mountains?
But you just give me 2 points, and we'll go from there.
Okay,
Yeah, that's funny because every time we give you 2 points, whether it's seafaring or airfaring, you guys always are traveling in a curved fashion. So why isn't it a straight line if that's the most efficient, precise way to travel from point
Yeah,
A to point B?
the Haversine function will give you a great circle path, which is a straight,
Yeah, exactly.
straight path over a curved surface.
Yeah, a straight path over a curved surface. How about a curved path over a flat surface, bud?
I mean, if that makes sense to you, but it doesn't make
Yeah,
sense to me.
that's what it is, because that's what it is.
Well, that doesn't make sense. Why would you take a curved path over a flat surface?
Because that's what you're doing anytime you're using your magnetic compass.
It seems like the wrong thing to do then, wouldn't it? Wouldn't it make sense to take a straight path over a flat
How
surface?
else do you guys guide yourself, man? Everything's based off your magnetics, your North Pole magnetics.
That's the point, though. On a globe, those paths make sense. Those paths which look curved on a flat map are actually great circles, which are the shortest paths.
Yeah,
on
you
the
guys
globe.
inverted it all, man.
Regardless, what I was saying to Fundy is the 2 points.
Yeah, put your protractor
the 2
away,
points, The 2 points we talked about.
Away.
Okay, I got you. The 2 points we talked about earlier, though, Fundy.
Well, I'm
they gave us the distance.
Hold on.
I'm just finishing up with saying what
Yeah,
I'm saying.
hold on. No. Fundy, are you even still here? Do you want to hear where Coach
He is still here.
Okay. Do you, Fundy, want Kosho to follow through?
As long as it's quick.
Yeah, it's very quick. I'm at the very end. I'm just saying that those 2 points that we mapped there, it ended up being the correct distance. And these other points that I posted below were from all the other people, flat earthers that I asked, like the distances that they're comfortable with, Google Maps having correct. And when I mapped those out, they also were the correct distance when I used that center point and created the curve with them. So, in my opinion, that tells me that that's the correct way to do it. That these positions are actually on a curved surface, because when you do that, they're all are the correct distance apart from each other.
Well, I would repeat the same point I pointed out earlier, but I think you got to address the modes of travel there and how inaccurate they probably were for every individual. I mean, there's a big difference between a straight line and what my speedometer or my odometer is going to say on my car. Yeah, sure. Roads aren't straight.
That's the reason why. That's the reason why in every one of these cases, all these examples that are on here, I prefaced it by asking the flat earther, like I asked you, I said, which one do you agree with is the correct distance on Google Maps?
I agree with the curved, winding, looping route that I took. That route was what Google said it was in length. But that has nothing to do with me saying that Google Maps has the right A to B distance in a straight line, according to your globe model.
Well, once again, like I said, these are from when I asked people that specific question. So if you don't think that that's the shortest distance, then that's fine. But maybe there's a miscommunication. But that's what I was asking. I was asking if you were confident that the Google Maps distance is correct. But that's fine.
On the winding path, there's still tons of room for error. But, I arrive a minute or two just on my way to work in the morning, earlier than it says I will. But, yeah, it's kind of apples and oranges here. Interesting graphics, though. I like watching them spin around, wondering who in the world was in Antarctica as a flat earther. Is represented by the yellow dot at the bottom that you put.
That was Jeremy. He said North Pole and South Pole. He wanted me to just plot those points, but he was kind of half joking when he did it. He said it, but I did it anyways.
Okay. Cool graphics. You kind of wasted your time plotting them all out like that. Maybe it was fun for you. I I hope you enjoyed yourself making these graphics. Look fun for me to look at.
Sure. There's a flat earther who was very taken from this. He even made a song about it. So it depends. Honestly, it really depends on how honest. That's why I ask people beforehand the questions, because if they're honest, they'll say what they agree with is the furthest distance that they can confirm. And if you agree that, you know, from China to, I don't know, Morocco is the correct distance, and then you plot them out, and then the plotted points are the correct distance, you know, all you can do from there is agree with it.
Well, few of
You guys
these, and
moved by
maybe
this, or what? You guys all
few of
lovers now?
few of these, and
Funny,
maybe
dude.
none of them are traveled in straight lines from point A to point B, though. So
It's
that
never
throws a wrench
traveled
in
in
it
a
all.
straight line. It's never traveled in a straight line.
That's what I just told you, man. You guys are using protractors and compasses, which are always taking you in a curved fucking fashion. Hence why I brought up Operation Broken Compass about a year and a half ago. Yeah, why
I
don't
can
you
tell
guys
you when
try traveling? Why don't you try traveling straight? You know, it's funny how you guys say it's really impossible to travel straight, right? But then you guys
Nobody said that. Traveling straight
Huh?
on a sphere is a curved path, and it's called a great circle. But that's traveling in a straight path.
Uh-huh. That's funny. I'm talking straight as a crow flies. If you were to set sail from Long Beach of Southern California due west, not using a compass, I'm talking straight. Where would you end up? Would you hit Tokyo, or would you end up in the southern hemisphere?
Well, if you followed it far enough, you'd end up in the southern hemisphere, yeah. Because
Uh-huh.
all great circles go in both hemispheres.
So now answer me this. So if I was traveling east straight as a crow flies, not using a compass, would I end up in the southern
I'll
hemisphere?
repeat it once more, but try to listen this time. All great circles end up in both hemispheres.
End up in both hemispheres. That's funny.
Yeah.
So you're saying, so what you're saying is that if I kept going, I would end up back in the same place.
I know you would end up in the same place, but when going all the way around, you would have gone in both hemispheres. And the only time that's not true is if you're on the equator.
Wait,
But
I'm lost.
at any other location, if you go in a straight path all the way around, you'll end up in both hemispheres.
Wait, I'm lost. Right, I'm lost. Okay, Kosho, it sounds to me like you're describing traveling along a long longitudinal line, and it sounds to me like the guy that was asking this question. I'm sorry, I don't know what your name. Was talking about east-west.
Yep.
So you're telling me
I didn't say anything about longitude lines. Yeah.
No. You're telling me You're telling me that if he travels in a latitudinal direction, he's gonna cross the equator.
Yeah, he didn't say that, did he? He said he travels starting west and then doesn't use a compass after that. That's what he said.
I said leave Long Beach from Southern California due west straight as a crow flies. That's
right.
my exact word.
Exactly. And then he said not using a compass again after that. You will go in a great circle path, which will take you south of the equator and then back again up north of the equator, back where you started. You'll spend equal times. You'll spend equal times in both hemispheres, because that's what all great circles do, other than the equator.
Okay, wait. Is he going in a diagonal?
All great circles go in a path that will take you south of the equator and then back north to the equator. You can draw this out.
That's the longitudinal line, dude.
No, it's not. The longitudinal lines are the great circle paths that go pole to pole. We're not talking about pole to pole.
A latitude, okay, the 60th parallel, right? That doesn't cross the equator.
Yeah, we're not talking about traveling the 60th parallel, are we?
Oh my God.
He said you start somewhere and then you go due east and you follow that path straight.
I gave you a specific Cartesian location that you can reference. And I gave you a specific vector, and I told you that we're not using the magnetic fields. We're using straight as straight is, like that's true tangent, meaning west. Due west from that harbor, and you're telling me I'm gonna cross north and south hemispheres. That's a little elusive to me because I don't see that to be true.
Well, Gambino or Flirt for Nerfers is here. He's trying to talk. I think he would end up 100% agreeing with what I'm saying, because it's the only way that happens. I mean, you understand that if you travel west, but you just go on a straight path on a flat Earth, you will go south.
No.
You can look at a sphere and do this. You end up in both hemispheres.
No matter if I did this going east, south, or west, anytime I'm not going north, I'll always end up in the southern hemisphere, and your camp openly admits this to me, and it seems a little suspicious that you guys aren't onto why that's possible.
That's how spheres work.
That's not how spheres work, bud.
Great circles, great circle paths. If you try to make a great circle path anywhere on the on a ball, you'll notice that if it's not the equator, you're going to end up be on equal sides of the hemisphere. You're going to equal time on both hemispheres. That's just how every circle, no matter what angle you put it at.
It seems a little suspicious to me, dude, that if I travel straight west, that I'm not hitting Tokyo. I'm going to hit the Antarctica. Seems a little suspicious to me that if I travel east, straight as a crow flies, that I'm going to end up hitting Antarctica. Seems a little suspicious to me that if I go south, straight as a crow flies, I'm going to hit Antarctica.
You're not going to hit Antarctica. I never said you hit Antarctica, man.
Well,
just because you're south, no, it's not. Just because you're south of the equator doesn't mean you're going to hit Antarctica. Actually, what's going to happen? What's going to happen is if you leave it from San Diego, you're going to end up about 30 degrees south on the other side of the world. But you're not going to go further south than that.
Unless the Earth is flat and you just start heading straight, and you're going to hit the shore of the pond.
True.
But I hear you on a globe. You're right in that model. Which is exactly what Daislow's test he would like to perform. He just wants to discuss with us any ideas of how we can be most certain we're traveling straight. What mode of travel and what system of protocols and checks and balances we can set in place to make sure we're traveling as the crow flies, as we said.
Well, one way you could one thing you can use to verify it is the total distance should be just about the same distance as the equator or any of the longitude lines. So make sure that that's consistent with that. And if you see that
I don't want to adhere to your system. I want some sort of device.
No one's asking you to adhere to anything, dude. We're just saying how you would verify that if you went in a straight path.
No, that's biased and in Narnia.
Yeah, exactly. Aside from your pathway you're trying to lay out, is there some type of device or tool or technology we could use to keep us guided traveling straight as a laser, straight as a crow flies, like none of this curve pathway?
Because we all know ropes will bend, steel beams will bend.
At least left or right, just staying on the surface of that boat, or that boat staying on the surface of that water, going straight. How could we guide ourselves straight, Kosho?
Well, I just was giving you one way to verify it, but you weren't happy with it, so why give more? You're just going to say, oh, no, I'm not using that either. Well, use whatever you want then.
Well,
the way I said it would be definitely a decent way to make sure that, when you're said and done, that you want a straight path. Because that's the same number that will give you the shortest distance.
You're talking to the wrong guy. The boat guy makes a good argument. I don't know what's his name, Kool-Aid. Makes a good argument for being able to. He says he will concede that you can't go in that straight line, but then he has something called VMG, velocity made good, and he can supposedly tell where that straight line is. I don't know.
It's really interesting when you're on a boat. How do you realign yourself towards a straight trajectory if you ever get pushed by a wave? Like, you need a visual, right? You need like the world's strongest laser ever, right? Some sort of super laser that's going to just shine in one direction, and it's always visible. But we don't have, what do lasers last? Like,
you can use the stars.
5 miles.
They can use the stars to determine their path.
I think that's probably a pretty good idea, but I think that there's still like room for argument when using the stars, as compared to like some sort of straight beam, that you can literally see on the ground next to the surface. letting you know you're going straight, or some sort of taut rope, some infinitely taut rope between point A and point B. It's tough. I don't know. I got nothing for you, Dice Flow. I hope you find an answer.
Yeah, I mean, I don't hear it being brought up much, and I think it should be talked about.
Someone's probably gonna think of something reliable, makes sense. Then the budget would come into play, but yeah, we'll cross that river when we get to it.
Well, at least with like gas and maybe a boat rental, I think it shouldn't be any more than maybe 50,000, between $10,000 and $50,000.
Do you think that the stars could keep you going straight, even though they're moving overhead?
Yeah, you have to have the almanac. So they move, but the almanac tells you where, if you have a watch, it tells you where they're supposed to be at any given time.
At whatever location.
Yeah, but you can use that same almanac to find your location.
You see how you have to like plug numbers into an algorithm to get the results, though? Where it's
you don't plug them into an algorithm. I'm saying you use the almanac, which tells you where the stars are.
The algorithm is in your head, man. You work it out. You fill in the blanks. There's A, B, and C that you look up in the almanacs, and kind of, you know what I mean, kind of balance the equation to give yourself an answer where you're at or how straight you've been going. It's a little removed from more like direct knowledge. Like, I know I'm going straight because there's a straight line next to me that sometimes I deviate a little bit off to the left, but then I correct myself and I get centered. Like lanes on a road, you know what I mean? Like lanes on a highway or a road or something. Not that those are perfect in telling you where you're going straight, but they can at least give you this visual of some sort to let you know you're inside or outside the lane, or crossing lanes or whatever.
All right, but wouldn't you have to have some sort of correction for your course? Like, say you're gonna sail all night. The sky is moving all night. If you follow a constellation or a star moving, you're not gonna stay on the same path the whole time, right?
The almanac is up to date, up to like times too. So if you're using it at a different time of the day, then you just use it for that time.
Right. Kosho's saying you need to refresh every 10 seconds.
You just need to know where the stars are going to be at any given time.
Yeah.
No, not an equation. You just need to know where the stars are. So if you know where the stars are, you can use them to trilaterate your position.
Yeah, the algorithm that I mentioned. You'd have to do it every 10 seconds and apply and compare it to your visuals and see if you're going straight according to that belief. And
that's the same. That's the same as everything. If you're using
the math,
whatever you're using to make sure you're going straight, you're gonna have to, look at it and make calculations.
It's just not physical enough,
It is. Yeah, you have to take physical measurements to do this. You take physical measurements of where you are in comparison to the stars.
To me, there's just such a disconnect that it wouldn't please anyone.
It's pleased people for centuries.
Someone has tried Daislow's experiment?
No, people have been navigating celestial navigation and sailing for hundreds of years.
Yeah, but that doesn't require going in a straight line. In fact, it's very adaptable, but not really. It's focused on getting you to point B, but it's not focused on taking you in a straight line over the ocean. I mean, like, you're gonna have to adapt along the way. The sun's gonna rise, the stars disappear.
Yeah, but then you can use the sun. The same purpose. But yeah, they often do want to sail on a straight path because it tends to be the shortest path.
They could try. They could try. But then there's also like water currents and trade winds that they're also taking advantage of.
Yeah, exactly. So they'll take advantage of those when when
Yeah,
need be.
so they're not traveling a
Not
straight
going to be in
line.
a straight. Yeah, they're not going to be in a straight line.
Well, if they're traveling on the trade winds, then they're going to go, the direction the trade winds are going. But they're going to
Which are
also
curved.
go the trade winds are going east to west, or is it west to east?
East and west is circular, dude. It's curved.
Yeah, but they go in a straight path. That's why they go from like the southern United States to Europe.
They go concentric around the North Pole. It's a curved.
Yeah, I know. I'm saying whenever they sail they sail this these routes. Like whenever you see the routes, they go like from the southern United States to like further north in Europe. Even though the trade winds curve around the poles, but the paths the ships took were usually straight paths. Any curved path is just going to take longer.
Yeah, it could take shorter if you're taking advantage of the curved winds.
Which way did they go? Eastward or westward? I forget. I think they went westward.
I think at different levels they go different directions.
Yeah, but the trade ones are specifically the mid ones. Yeah, but yeah, you're right, because the ones from 60 to 90 they go a different direction, and 0 to 30 goes a different direction, and the one in between them goes in the opposite direction.
You ever think how baffling it is on a globe for these winds to like be outpacing the spin of the Earth?
No, that makes sense, doesn't it?
Oh,
yeah. Doesn't that make sense because of the Coriolis?
No, they're outpacing it in the same direction it's spinning. They're spinning faster in it in the same direction.
Yeah, but they're higher up, right?
Yeah, which would make them lag behind, like the outer loop of a racetrack.
I always thought they were because of the Coriolis.
Coriolis is exactly why they would not go faster.
Let me see here.
If something's higher, it has a longer distance to travel. If it was going the same speed, then it would appear to lag behind. Now it's going to need some sort of fuel source to power itself and propel it faster and win the race, even though it's on the outer loop of the track. Not a problem on flat Earth. I mean, winds are free to go wherever the fuck they want, flat Earth.
Yeah, that was
Blow
my
any
question.
direction.
Where I was thinking about are the Google Map miles air miles or land miles? Like, right? So it would be interesting to me. So if I go to delta.com and say that I want to travel from Baltimore to LA, it's going to tell me 2359 miles. Are those air miles? And then if I say
surface.
and then if I say, okay, I'm going to drive that distance, is it going to tell me 2359?
I believe, entertaining the thought that you could drive in a straight line too, or is that what you mean?
Well, I'm just saying. I'm just wondering if I have Google Maps, and I plot out that I'm going to drive from Baltimore to LA, and it shows me 4 different ways that I can go, and I choose the fastest route, which is presumably the one with the least amount of turns, right? And it tells me 2359 miles, and then I go to an airline to then say I'm going to buy a ticket and see how far that is. Is it going to be the same distance? Because it tells you how far the flight is. It tells you how long you're going to be in the air, and it tells you how far it is.
Well, there would over a long flight, the flight distance should be longer than the surface level straight line stretch across the surface.
You mean over a long? What do you mean over a long flight?
Over a long flight would be most noticeable rather than a short flight. Whether the length of a flight from point A to point B appears to be much longer than a hypothetical drive along the surface of Earth to point A to point B, if you could drive in a straight line, like a plane can more easily do.
I don't think I understand how you answered my question, but anyway, I just think that that's interesting. Again, that brings my question up. When you look at Google Maps, is it land miles or air miles? And when you ask about Delta and how long the flight is going to be, and they show you the distance, is that air miles or land miles?
It's over the surface.
Land miles have to go on roads, which are not straight lines. So that's why I was saying surface miles, not land miles. As a car.
Okay.
Because a car, road miles are always going to be longer than airplane miles, even though if you could drive from point A to point B, it'd be a shorter distance than flying to point A to point B, because the airplane is higher in the air and it's got a bigger arc to complete.
Okay. So my question then now is, how many more miles is a flight going to be than driving?
Driving in a hypothetical straight road or driving on the road?
No. Just look. I'm not trying to make this any more complicated than it needs to be. I'm just saying I'm going to pull out my atlas, like my atlas, right? My atlas shows me the east coast to west coast. I've got a legend down at the bottom that shows me, how far 50 miles is, or 150 miles, or whatever. And I plot that out, and I look and see that traveling from the east coast to the west coast is 2,472 miles. I'm asking now, if I then go to Delta, how many more miles is Delta going to be than my drive?
Right. Like I said, it depends on the length of the flight, and it's going to be more noticeable the longer the flight. And all you got to do is compare.
No, because the length of the flight, right, is either 5 hours or 5.5 hours. That's how long it takes. I'm asking about the distance. I'm not asking if it's going to take long,
Yeah, I hear you. I feel like I completely understand. Was about to give you a really good answer.
Okay.
So if we're entertaining the globe, then what we're talking about is crossing over a certain arc of Earth's curved surface, and the arc that a plane does is going to have a larger radius, a larger distance from the plane to the center of the globe, and so you're gonna measure out these arcs by using pi times the radius squared, or I'm not squared, two radius, the diameter. So 2r times pi is going to give you the full circle, which is going to be larger for a plane than it is for a car. But it's not going to be to like a really large degree, because the radius from the center of the Earth to a car versus the radius from the center of Earth to a plane is not that much compared to each other. They're going to be very similarly length lines overall.
Yeah, if you go around the whole Earth at 50,000 feet, then you're adding 36 miles to the trip being that high.
Okay, so then let's just say Earth takes up. America takes up. I don't know.
Here's something else.
Seventh of a circumference.
So about 700 miles. About 700 miles. Every 700 miles, you're adding. I think you're adding 1 mile. So if you travel 700 miles in a plane, the trip is 1 mile longer than it would be along the surface. So every 700 miles on a plane, it's 1 mile longer than the surface distance.
There you go. That's a good answer. Thank you.
But I don't think they use. I think they just use what do I call it? Ground speed or ground distance, right? I always get trade winds confused with jet stream. I'm reading about them now, trade winds. And
Right, jet streams is what we were talking about. Those are the ones that you're going to take advantage of. The jet streams.
Oh yeah.
They're the
Well,
ones-
I mean, because those are consistent. Yeah, those ones, they're the higher up ones. Trade winds, I don't know if they're faster. I think that they're just. I think they're just consistent, consistently in the same direction. But yeah, I think trade winds are faster though. I mean, not trade winds. I'm sorry. Jet streams. Jet streams are faster.
Yeah, trade winds are more willy-nilly and spirally and all over the place, while jet streams come in like 4 different strips or 4 different like halos above the earth that are really consistent and one directional each. Those are the ones that are taken advantage of with the fake satellites and balloons and stuff.
Oh yeah. Right.
But then there's like upper jet streams that go opposite directions. It's crazy because they say they can control the path of a balloon by lowering and raising its altitude because the winds above are going one direction, the winds below are going another.
Well, that's not just jet streams though. That's like if you become a hot air balloon pilot, you got to take meteorology classes too because all different altitudes, any change in even a little bit of altitude, the winds could be going a different direction. But you're right with trade winds; they're consistently going the same direction. But on your path up and down, they'll change every what is it like tens of meters.
What would cause
Weird
that?
shit, huh? Yeah,
That's how
right.
they-
Weird
that's how
shit.
that's how they navigate. That's how they like turn and shit. That's how they pick the direction they're gonna move. It's by just
Yeah,
changing
what would cause those winds to be totally opposite direction? I've found it to be sometimes like 2 to 4, 5, 6,000 feet difference. Like we'll get into a headwind and we'll ask for a 2,000 foot variance so we could try and find a different, at least get out of the headwind.
Go in a plane.
Yeah. What causes those winds to go in 2 separate directions?
Changes in the
like
the
that
pressures.
close together.
So it's just like I use the analogy of just a boiling pot of water or something like that. But if you have something like a boiling pot of water, which has temperatures in some places that are very hot and other places that are not so hot, you just got a lot of the turbulence and moving around. So it's really just a different, pressure cells just moving the air different directions.
I'm not satisfied.
I mean, it's not
Yeah.
it's not gonna be a consistent thing though. So it's like you would imagine it's there would be some winds going some direction, and you go somewhere else, the winds are gonna be doing something different.
Well,
Shit's
when
gonna
you
do what shit does.
throw
huh?
in the when you throw in the rotation of Earth pulling the said due to the atmosphere, and then you factor in all the winds going in different directions, the trade winds often being so set in stone. I mean, you can almost map it out, year by year. It seems like it has more to do with the position of the sun than it does anything else.
That's part of
So
it. For
trade
sure.
winds are, yeah.
Because that's it. They're going the pressure. The least pressure is where it's hotter, and because both directions, the high pressure is moving to low pressure.
Right, temperature stuff.
But in the globe model, it'd have to be the angle of the sun, not actually its position.
Well, no, it's
relatively, it's the same distance away.
Yeah, but it's always over the tropics. I mean, it's always tropic to tropic, moving back and forth from the equator. So it's consistent. It's consistently higher or lower pressure there, like always.
Yeah, that's where the action happens, in between the tropics and in the ecliptic. I wish more people really understood what the ecliptic is.
Why you say that?
Walk me through it.
So the sun does change its position on the horizon where it rises and sets, and it ping pongs between a thin strip of the horizon, whether it's setting or rising, and it's the same thickness along the sky as if there's a sidewalk or a road that the sun always stays within the lanes of.
Like a path.
And what is it? I don't know, 23 degrees, I think.
Well, yeah, it travels 23 degrees west or north and south, but yeah, all the planets are stayed there. Well, they're right about on the same path, and the moon's pretty close to the same path, and the zodiac stars, yeah.
So all the things that we call planets, and the sun and the moon, all live within the ecliptic, and it's the only road they travel upon, and that's what sets apart the zodiac constellations from all other stars, because the zodiac stars are the stars that the sun will travel along with throughout the day. Of course, the stars will outpace the sun, with the background stars making 366 laps per year, while the sun does 365 laps across your head per year.
The moon's going even slower.
Resets every year, right? On a certain date.
What'd you say?
It's perfect every year, right?
No, it's so when I said 366, what I really meant was 366.00001, so that every 2,600 or 25,920 years, there's also another lap done. It's just like racing cars, and someone laps the other car, but not perfectly, so that every 2 laps I make, or 366 laps I make, you make 365. It's like, it's not exactly perfect.
Yeah,
the stars,
yeah, exactly.
It's the easiest way I can explain is that in 1 year, every year the stars outlap the sun once, and they outlap it with just a little bit extra that builds up over time, like interest, and then after 25,920 years, an additional extra lap is made, more so than the sun. So every year, and another time every 25.
All right, so let me ask a question real quick. Okay, so if I'm going to start watching the sun now, because it's winter, anyway. So you said there's 23 degrees, right?
Yeah. So
Okay,
go to your backyard and stand in the same spot every morning or every night.
Okay. Right. So think of it like a time lapse. So if I had a time lapse of the year from my backyard, I would only see the sun move within a 23 degree section.
Yeah.
Is that what you're saying?
Yeah.
Okay.
I could be off on the degrees, but it's something low like that. It's not drastic. It's a thin strip of sky. So if you like stand on your back porch and your back porch faces the sunrise, and every day you go to the same position on your back porch and you take a photo of the sun rising, just when half of the sun has poked up, and you take a picture every day for 364 days, then if you play those like a slideshow, you're going to see the sun being like the ball in the game Pong, just going left, right, left, right.
Yeah.
You remember
Would you say that would work on a?
Yeah, I mean, it's easily explainable on a flat Earth.
You just got to double it 23 though.
Double the 23? Oh yeah, so
yeah.
maybe it's 46 degrees, 23 southern of the equator, and 23 northern of the equator. And that's the sort of tighter and looser circuits it performs around the North Pole, whether it's going slower and tighter in circuits or outward and slower, like someone taking a flashlight, shining at the ground and spinning at a steady rate, and then pointing the flashlight a little bit further out and a little bit closer to their feet.
Yeah, I observed that. That makes more sense. It also makes more sense with how the warmth that I get from that apparent heat source, light source and heat source. When the sun appears to get further away from me and is lower in my sky in my winter, it sets more towards the southwest in my area.
Right.
And then and it's cooler. It's my winter. And then in my summer, when it comes more directly over me, it would make sense that that light source is closer to me. It's at a less angle, straighter over me. So it gets hotter here during my summer months. And it seems to be in a tighter circuit because it sets more towards the north, you know, more west, northwest, you know, in my area. So it makes sense to me on a flat plane.
It's all right on a globe too. I mean, it's all right. I mean, you got to give the globe kudo points for you know, aligning a lot of things with their model. I think it falls apart when you hold up scrutiny, but a lot of it does a pretty good job holding up.
Well, I do agree that you can take the opposite, right? You can have the Earth stationary and the sun, moon, and stars circuit above, and then take the sun, moon, and stars basically be stationary in relativity, and then make the Earth rotate at the same speed. I understand that philosophy. The one thing that gets me about the sun, though, is the heat from it. During my winter, when in the winter on the globe model, it's actually closer to me, but at the same angle in the sky, I don't feel it as much. Now they talk about other things, but you have to really start jumping through hoops. It just makes more sense on if that heat source is closer to me, it's going to be hotter. When it's further away from me, it's going to be cooler. It would also be you know, lower and higher in my sky according to the distance that it is away from me. So just makes more sense. You know, I'm not saying the other model doesn't make any sense. I'm just saying, you know, the flat Earth quote unquote model makes more sense when it comes to that to me.
Yeah, it's on a flat Earth. It's as simple as having a heat lamp over something. You know, the more directly above the heat lamp is to you, the hotter you'll be. If a heat lamp is directly above you, it's going to make you hot. If a heat lamp is off, you know, in front of you somewhere, it's not. It might heat you a little bit, just not as much as it would be if it was directly above you.
And you can take that same lamp and put it above you, and have it travel away from you, and it would disappear bottom up just like the sun does. It's on a flat surface. I mean, you can test that for yourself. I don't see any issues with either model in that. Yeah. Now on a sphere, the sun would disappear like they say too. Over a sphere, you know, if we're going away from it and the sphere is, you know, obstructing, of course the bottom would be obstructed, you know, first in most cases, just like it is. But it's not always obstructed, you know, like that. Sometimes the atmosphere does get in the way and it just kind of blinks out. So that could work on both models, I believe, too.
I was telling someone today about what your last sentence, and I heard it called the cloud deck once. That's how I explained it to her. You ever heard it put that way? The cloud deck?
Yeah, it could be a number of things, right? I mean, in the distance, if the sun is 1,000 miles away or 3,000 miles away from you or 10,000 miles, there would be objects that are taller than you out in the distance on a flat plane that would obstruct it. You just wouldn't see those objects, you know, because of the atmosphere. You can't see infinitely far. So those objects are obstructed by the atmosphere. You can't see them. You're not getting that information. But if the light source went beyond them and appeared to be below them, it would obstruct that light. You wouldn't see that either.
Exactly. It looks like Kosha left, but I wanted to ask him a question. But I'll just ask you guys instead. Let's see, what was it? I forgot. I'll get back to you. I'm sorry.
So what did you want to have clarity on the ecliptic? Just that it's within that 46 degrees?
Oh yeah, I'm sorry about the background noise, but yeah, I wish more people understood that, you know, Mars, Venus, Mercury, Venus, Mars, Jupiter, Saturn, and the Moon and the Sun all live within the same thin strip across the sky, and the zodiac belt is the road that they travel within, and that's what gives the zodiac its prestige against all other constellations. And the fact that on a annual level, it does one ping and one pong, and that you don't need to believe you're going around a sun to understand what a year is. Year is a visible phenomenon. That's another one of those branches of understanding the ecliptic and the way it performs what it does, that grounds you in what I like to call feet on the ground based astrology, or feet on the ground based astronomy. Like, what does it look like? You know what I mean? I don't care about, like, imagine a ball spinning, going on a bigger ball, flying through space. The ancients didn't care about that shit. The ancients and all these, like, holy books and texts, right? They're going to be operating it based upon, you know, what I call feet on the ground perspective astronomy. What does the sky look like it's doing? You know what I mean? And when you understand like that, you can understand that the stars move across the sky faster than the sun does, and the moon travels across the sky slower than the sun does. All right, maybe I might have messed with my words. The stars are fastest, then the sun, then the moon, and I actually don't have a clear understanding of the speeds of the different planets. That, I guess, a little complicated, but because they slow down, they speed up when it comes to the planets. But I do know that Saturn has the slowest change in its position in the night sky per night, which is why it gets turned into Kronos, or, you know, one ring to rule them all, Grim Reaper, old man time sort of thing, where if sickness or disease or murder doesn't kill you, time will win. That's why it's one ring, Saturn's rings to rule them all, the god of time. He wins in the end. He's undefeated. Time is undefeated in battle.
I don't understand your metaphor. Can you kind of unpack what you're talking about with Saturn? What?
Yeah, so no one knew Saturn had rings until Galileo, I suppose, right?
Was Saturn one of the 7 wandering stars?
Yes, so with your own 2 eyes, a little connection you can have to, like, all ancestors of everyone throughout history, as long as you're not invoking some sort of, like, Tartaria advanced civilization with, you know, like, super technology back in the day, right? If we're just going by, like, the mainstream history, where, like, civilization is only 6,000, 7,000 years old or whatever, then when it comes to the ability for humans to observe the sky, Neptune, Pluto, and Uranus do not exist. They're not visible. No one's ever seen them. This is something brought to us by NASA. But when it comes to Mercury, Venus, Mars, Jupiter, Saturn, even next to all these city lights I live next to, I can still see these planets. Anyone, almost any night of the year, can see the five visible planets. But the 5 visible planets are the only planets your ancestors ever knew about. So when it comes to the 7 days of the week, or the 7 lights of the menorah, or the 7 chakras, and all these ancient systems, you know, chakras are nodes of light, you know, balls of light within your body. You got the menorah, 7 lights. You got 7 days of the week, the 7 daylight cycles. Why? It's all because throughout history there were seven special luminaries that set themselves apart from all the other stars, as we call them, that stay in the same position year after year after year. But the seven, holy luminaries are the only ones that bring the sort of spice to the sky. They add variety. They're somewhere different every night. Saturn is the one that changes its position the least amount per night. And then Jupiter is second, and then Mars third, and then Venus second. Mercury changes the most. That's why you always hear Mercury's in retrograde, because it's the one that has the most fluctuation, because it's at the bottom of the list.
Okay,
And
so
then
but
the
go
sun,
back. Okay.
Go ahead.
Go back to the whole death thing with the One Ring.
Yeah. Okay. So Saturn is Kronos. That's sort of Greek-Roman connection, where like the Romans ripped off the Greeks or whatever. You heard of that before? Where like the Roman. So Saturn is Kronos. Kronos is the god of time, and he's the daddy of all gods. Well, when it really comes to it, Saturn is Kronos, is that light in the sky that moves slowest. But in Greek mythology, Saturn did have a god, and Saturn did have a dad, and his name was Uranus or Uranus. But to the Greeks, Uranus was the sky itself.
Right, that's what the word means. Yeah.
So the way they were looking at it was, they had the seven luminaries, they had the seven planets, which include the sun and the moon, because if you Googled the seven classical planets are the five visible planets that we call planets, and then the other two that make it seven is the sun and the moon. So the sun and the moon.
I'm sorry, just real quick. So to slow it down, just real quick. Planetes in Greek means wandering, right? So there's
I'm not sure.
So there were. No, I'm telling you, that's what it is. Okay, so the word where we get the word planet is just taking the Greek letters of planetes into our word for planet. So if we want to say that, what's the etymology of the word planet? It just means those things that wander. And the reference is those things in the sky that wander. So it's referencing the lights in the sky. What's interesting to me, and I've always wondered this, is why they named another planet the word that simply means sky, Uranus, right? It's not Uranus. That's a white boy redneck pronunciation. It's Uranus, the Greek pronunciation. So
I can tell you.
Okay, why did they call something that's not the sky? Why did they call it the sky?
Right. So okay, so I'll tell you. This is awesome. The wandering stars, the planets have, in so many cultures, been named after and associated with gods, because that's probably where it all started. Just this honoring of the sky, which was heaven to them. Like to ancient people, I imagine, like they looked at the sky and they said, "That's above me." If the holier you are, the more enlightened you are, the higher you are, the holier you are. You know what I mean? So the sky has always been associated with holiness and divinity. You know what I mean? And it's only until recently we just view it as some sort of infinite void filled with a bunch of balls and a bunch of other aliens or whatever. Where the sky is just not ambiguous, but whatever. Anyways, so every culture, it seems, has this sort of game that it plays. I like to just call it a tradition. The tradition of relating the sky to divinity. And Uranus is the god of Saturn, or Kronos, which is already set in place. So the names of the stars are something that Americans have already inherited. We just grow up with this tradition that was given us by ancient cultures of calling those 5 lights in the sky, the names of gods. And so then they discover a new one, and they say, well, if the furthest away planet god is Saturn, and we find something that has for him, meaning his orbit is within someone else's orbit, like his domain, like you can be a governor, or you can be a mayor, but the governor has a larger domain, and then there's a president that has a larger circumference or domain over the governor, right? Uranus is recently discovered and thought to have a larger orbit circumference and larger domain, which he rules over, which he keeps everyone else inside within his kingdom. And so they just carry on the tradition that has always been carried on, where it's like, oh well, who owns Saturn or who owns Cronus? Oh, Uranus. So we're calling, just like Jupiter is the son of Saturn, Uranus, just like Jupiter is the son of Saturn, Saturn is the son of Uranus in Greek mythology. So when they discover something that they say has a larger orbit, or a more distant orbit than Saturn, they just follow the tradition of daddy son pattern, and they say, oh, let's just name this next one the father of Saturn, which was Uranus, even though the way the ancient Greeks saw it was that the sky itself was Uranus.
Got it. Okay, so that's an interesting, I guess, intentional misdirection because of what the original use of Uranus was. But okay, so
it fucks it up a little bit. Yeah, it fucks it up and confuses people, right? It's a little unnecessary, but in a sense they are following an age-old tradition.
No, I get that part. Yeah, I get that part. So my question is, again, because I'm not an astronomer. Okay, so now what you're telling me is that Jupiter is closer to us than Saturn is, right?
Right.
So why wasn't Jupiter ever visible to the ancients if it was closer?
It's always been visible. Everyone, I see it every night.
No, Jupiter. Okay, wait. Oh, Neptune. You were saying Neptune?
Uranus, Neptune, and Pluto cannot be seen by anyone besides NASA.
Right. Got it. Okay, I got it. Okay. For some reason, I was confusing Neptune and Jupiter. Okay. Yeah, no, that's a good answer. I appreciate that answer. Thanks.
Yeah, you're welcome. So Neptune is Poseidon, and this is where the tradition falls apart, because when you have Jupiter, Saturn, Uranus, that is that is son, father, father. You know what I mean? Like Jupiter was born from Saturn, and Saturn was born from Uranus. So at least when it comes to those three, they have like a Greek hierarchy, like family, father-son hierarchy dynamic going on. But the tradition is completely thrown away because Uranus has no father. So at that point, they just didn't know what to do. So they just chose some other bullshit. Said, Poseidon, Neptune, whatever, same thing. We'll just call that Pluto. He's the god of the underworld, or he's Hades. And at that point, I mean, Hades makes a little bit of sense because he's in the darkness of space where like the sun's light barely reaches him. So he's like furthest, and like he's so cold and frozen, like hell. A lot of people think of hell as like fiery, and that's okay. But there is a relationship between the words inferno, which means hell, and inferno, a fiery hell. But then the word for winter in Italian is called inverno, and F and V are the most similarly phonetic letters in the English alphabet, because in order to pronounce an F sound and in order to pronounce a V sound, inferno versus inverno, an F and a V both are the only two letters in the alphabet that make you bite your top lip with your bottom teeth to pronounce the sounds. So there's a big connection between like when hell freezes over. You bite your upper lip with your bottom teeth. No, that's right.
No, you bite your bottom. You bite your bottom.
Bite
lip
your
with
upper lip with your bottom teeth.
No,
No.
you no. Say the word. Say the V right now. V. Your bottom lip touches your upper teeth.
That's not how I use my mouth, man. I don't. I guess both are an option, maybe. I don't know. Let me try. It's either way, I guess. I guess it depends where you're born. I guess you can make a V and an F.
Wait a minute. I can. Okay, what you're telling me to do is to throw with my right hand, and I would end up throwing like a girl. So I'm gonna make a V or an F right now, touching my upper lip to my bottom teeth. That's like an underbite.
No, you're right. You're right. No, you're right. You're right. I'm sorry.
Okay.
No, yeah, I got an opposite. Now that
That's why. Yeah.
I had to touch my face with my fingers to figure it out. I don't know why.
Yeah, but that's why you do that little joke with mouthing olive juice to someone.
Right.
Olive juice.
I love you.
Right.
Exactly. Yeah, that's a good one right there. Here's a little since we're on the topic of stars and gods and stuff and words. One of my favorite series of like who in the world like set this up. When it comes to words and the zodiac and planets, you have Mars. Mars is very similar to its counterpart Aries, which could just add an M to the beginning of it, and now it's Mar-Ease or Mars. You know, Aries, Mars, very similar. And in astrology, Mars rules over the constellation Aries. Now, Aries is Ram, which is Mars backwards, M-A-R, R-A-M, Ram, right?
And that's the symbol of Aries?
Yeah. Aries is a ram, which is ruled by Mars. And all of these words, Aries has an A-R, very close to an M-A-R, so just extremely close. But an Aries is a ram, which is Mars backwards. So I feel like the connection is not like a stretch or anything. So right off the bat, we have Aries, Ram, and Mars all being related. Now we have Mars being the god of what? War, which is Ram with a upside down M, or Mars with an upside down war. Mars is the god of wars. That's just taking Mars and taking the M and flipping it upside down to a W, because M and W are the same shape, just upside down from each other. So Mars is the god of wars, right?
Yeah, this is where you lose me.
You can't imagine an M being flipped upside down.
No,
and becomes a
I
W.
can. Right. No. I can do the imagination part, sure. But I would want proof of the justification for that. So it's not simply associating. It's like correlation is not causation. I completely I completely get you. I get what you're saying. I just meant I hear you, but yeah.
Okay, well, the most I can realistically hope for is just your understanding of the correlations I'm drawing. Because I'm not speaking on causations right now. I got two more, if you don't mind.
Okay, go ahead.
So far we have Aries, Ram, Mars, War. And I'd like to add, in addition, that Mars, which rules Aries, is the month of March. So even the name of the month that Mars rules over is called March.
And what do you do in war?
Oh, you Mars. Oh, and here's another one. What are wars fought with? Arms, which is Mars rearranged.
And what do you blow when you're ready to charge into battle? Ram's horns. What?
Whoa. Fuck yeah.
Yep, and
That's
the
true.
spring equinox is also in March, which is like Mars's energy is usually it's a forward moving cardinal directional type of energy. So it's all about initiation, new beginnings, and so on. So when that spring hits and you get that spring equinox is in March as well.
Here's my last one, and then I'm done. In modern day astronomy, they have a coordinate system for the sky sphere, as they call it, with the sky equator and stuff like that, whatever, celestial equator, right? And the celestial meridian, prime meridian, right? The prime meridian of astronomy begins at the constellation of Aries, the Ram. And what is the abbreviation for the prime meridian in the astrological whatever I called it? It's called right ascension of meridian, RAM, right ascension of meridian, starting at the Ram, the RAM. They're like I said earlier, modern astronomy plays along with the naming of Uranus and right ascension of meridian being RAM at Aries, which they place it at. They're just carrying on a long-held tradition.
Okay, but
Just
see the
playing a
thing,
part.
right? So the thing for me with Ram, because Ram is an English phonetic word. So how far back in astronomy?
question.
How far back in astronomy is the symbol for Ram associated with Aries? So did the word?
Really far back.
So was the word Ram created?
It's out.
To represent the animal, right? Because an animal, say, what's the word for ram in German? Because if you think about English is the most bastardized mutt of language at all, because it takes from Spanish, Latin, French, German. It takes from everybody.
Yep.
Everybody, right?
Yep.
At least everything that's Occidental, not Oriental, but Occidental, right? So,
right.
So
Ox.
then
There you go. I'm sorry. Go ahead.
Yeah. So when you bring in the RAM of the meridian thing, I'm just thinking, okay, these guys are just fucking with language, and so they create the English word ram based on all of this.
Right. Esoteric shit, right?
Yeah. That's really interesting.
Yeah. People, there's a big joke being played when it comes to astronomy. I mean, you know it. I mean, yeah, they've had a lot of influence on the way we name and talk about and discuss what the sky is. There was one more thing. Oh, you're saying? Oh, yeah. Here it is. So, just to add another layer that I hope you understand as like nothing but obviously intentional, is that the two phonetic letters, or the two phonetic sounds that are most heavily related to each other are R and L. They're called the liquid letters. That's why Japanese people have a hard time using R or L properly when like learning English, right? They go, you know what I'm saying, right? I rub you wrong, you know what I'm saying?
Yeah.
R and L are the most similar to each other than anything else. And so you have ram, an adult sheep, and you have a baby sheep, the lamb. Lamb and ram are the same word because R and L are alternatives of each other. Lamb and ram.
No. How do you say that? How do you tell me that they're alternatives of each other? What does that mean?
So there's a chart that was made in 2015. That's, I think, the most modern version. It's called the International Phonetic Alphabet Chart, the IPA chart. You ever heard of it?
No.
So the IPA chart, the International Phonetic Alphabet, is the association. So there's one IPA and then there's a second IPA. One is the International Phonetic Association, and the International Phonetic Association invented the IPA, International Phonetic Alphabet. And these are the symbols you see when you look it up in the dictionary.
where you see like AE, like combination symbols, upside down P's, and like all those funky letters that are like trying to tell you how to say it properly phonetically.
Right. Yeah.
So the latest chart is from 2015, and what they did is all the linguists around the world that came together with every known language and gave every distinct sound the human mouth can make its own letter. So no more of this English bullshit where the letter A makes A, right? In English, the letter A has 4 different. What they did is they removed that convolutedness, and they discovered and recorded and noted every single sound the human mouth can make and gave it its own symbol. And in doing this, they developed an understanding of what letters or what sounds are close when it comes to the muscular constrictions of your mouth to perform each different sound, which sounds are closest to other sounds. And R and L are a single twitch of a muscle away from each other, just like P and B are alternatives of each other. T and D are alternatives. F and V are alternatives. One is
I don't
called
see that.
Okay, well, let me just explain it. P and B are called the bi.
I get
Okay,
those
go
parts. I get those parts. I get those parts. The R and the L, my mouth moves in 2 different directions. R is forward.
Yeah, I can explain.
Okay.
So, R and L are categorized as liquid letters, and I already explained how Japanese people use a sound in their speaking with a hybrid of both. Japanese people speak with an RL sound at the same time. And so when they read an RL sound, they make the same sound that they normally use because they aren't used to the hard American R. Right? We say R is and L is ooh. They perform the hybrid in their language, and they don't have either one. But they're considered the liquid letters because with all other consonants, you have to constrict and close off some part of your mouth in order to make that sound. You have to constrict your muscles, build up air pressure behind it, and then release it quickly, like you know. And so liquid letters are the 2 letters. There's a few, but these are the pure versions, L and R, where you constrict your mouth only halfway. L and R are able to be made. They're considered consonants, not vowels. But the thing about L and R is that they're hybrids between consonants and vowels, because you only constrict your mouth halfway. One raises your tongue higher, one sucks your tongue, back deeper into your throat. But L and R are liquid because there's a slight constriction, but there's never an occurrence of an actual blockage that creates pressure. It's like, because you can go oh, but you can't go p p p. You can't make a continuous p sound. So that's called a trill. But L and R, the trill version of R. So there's different trill versions, but they're not liquid, they're trill. So that's why L and R have the most in common.
Okay. Wouldn't it be then Rickrid?
For a Japanese person, I mean, that's probably how they say it. Just being honest, they struggle with the hard R's.
Is that only Japan? It's not all Oriental.
I'm not sure. I'm not sure.
Yeah.
Could be. Yeah. Who knows? Someone.
Because I always thought it was Chinese. Because remember in A Christmas Story when they go out for the Christmas dinner for the goose and they were singing fa ra 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 ra.
Yeah, it's probably both then. Yeah, it's probably both. Because there's a Japanese cartoon where the main character's name in America is Goofy, and but they were saying it in Japanese. They're saying Rufi, Rufi, and so then it started in Japan, but then they had to translated in America. And there was a debate for the longest time in America. It's like, what's the proper Americanized, localized way to pronounce this main character's name? And so you'll find episodes where the voice actors say Roofy, and you'll find other episodes where the voice actors say Luffy, depending on which production studio is making it. Because it's either way. Because what those people use is a hybrid letter between L and R. So it's and then the author came in and he gave the official declaration on how he wants Americans to pronounce the name, and he chose L. So now the main character's name is Luffy, even though there's people for years and years before he spoke up who were calling him Roofy, because the way they were saying it was like Roofy, you know what I mean? It was unclear because they use a sound that we don't. Because out of the 140 different sounds human mouths make, English only uses like 36 or like 40 or something.
Very interesting, man.
Thank you. I'm glad that wasn't a bore.
No, not at all. Not at all. It's the first time I've talked to you. So are you normally in 24/7?
I'm usually in the pseudoscience science debate Nathan Oakley place.
Okay.
You probably know the one.
Yeah, yeah.
But I'm going to be here from now on because it seems like this server killed that server.
Yeah, we'll see. It's only a week old, right? 4 days old, maybe, or
Right. Where do you usually spend your time before this server was made?
Brandon's.
Oh, I'm there too. It gets really
Yeah,
serious over there.
Who, me?
No, not you. It gets really serious at Brandon's. The topics are like hard to speak up on because the people are going so rapid fire pace. It's like, where can I find a chance to speak up? You know?
Yeah. I came in hot this week when I came in the first time, and Merle was all shutting me down. So it was like, okay, I guess I'm gonna have to tighten up on here, and I don't mind that. You know what I mean? I actually wish that Brandon would be a little bit more heavy-handed over there, because I like having conversations like this rather than talking over somebody. But
totally.
So I came in I came in used to Brandon's this week, and Merle was like, "Yeah, we're not doing that here." I'm like, "Okay."
I'm a fan. And Gio's a cool guy. I'm happy he started the server up.
Yeah.
I like his rules that he outlines. Not that they've been being followed too recently, but I like the power it gives people to like call people out. It's like it's literally written that we're not going. It's against the rules here to like yell louder to make your point made. You know what I mean, or your point heard. It happens, but I like that it's written down somewhere. It's very, very detailed. But oh right, so my whole rant about the International Phonetic Alphabet, which I'll go ahead and send you a image, a chart. It's really fun to look over, and but there's more to it than meets the eye at first. The way they organize their charts, but it was all about how lamb is the same word as ram, and they're the same animal. Just one's a baby, one's an adult, right? A baby ram is a lamb. And that's because, and they chose that because L's are the same thing as R's phonetically, or most related phonetically. You'll find a lot of connections in words when you understand what's called the breathed versus voiced alternatives of each other. Like the difference between F and V and T and D. One involves the vibration of the vocal cords, and one doesn't. So T you can make just by breathing, just but you have to actually involve your vocal cords. It's the same mouth position, but you throw a little extra effort into the vibration of your throat to turn a T into a D. And so they come in pairs. So T and D are a pair, P and B are a pair, F and V, L and R, and G and K, G and K, G, G. You know, so those will take you a long way, to be honest. And there's obvious ones that aren't breath and breathless version or breath and voice versions, like M and N. That's more about where you lift your tongue to force all of the vibration to come out your nasal cavities when you use the N. Probably why the word nose starts with an N is because it's the sound that N, or it's the path of making the letter N. Nose, you know.
Yeah, but you could have been Moe's too, though.
Right, but you lower your tongue and you don't when you make an N, you raise your tongue to block off the path to the front of your mouth. Like you close off the resonance chamber of your front mouth, and you make all the resonance go through your like nasal cavities to make an N. But then you lower your tongue to allow your mouth, mouth, to make the M sound.
I gotcha. Yeah, because you got
Mouth
more
and
vibration. Yeah, you got more vibration on your lips with M than you do with N. Yeah, I gotcha. No, that's really interesting. I'm just wondering who uses the IPA, right? Like it's like
It's the fastest way to learn any language, because if you understand the IPA, then you never have to ask a native speaker how a word is properly pronounced. That's like the coolest part about it. If you know how to read the International Phonetic Alphabet, you never have to ask a native speaker how a word is supposed to be properly pronounced, because you can just read the sounds as individual letters instead of guessing what if the A is a or a or a or an A. You know what I mean? There's no guesswork involved. It's just simply laid out.
I wonder if that's why English is so hard, is because it borrows from German and Spanish and whatnot, and the way that you pronounce the vowels in Spanish aren't the way you pronounce them in German. And then if you just write a German word in English and a Spanish word in English, you're going to butcher them.
Right. You know how the word no starts with a K?
Yes.
And do you remember what I just told you K is an alternative of?
No, I can't remember what you said.
So if you make a K sound, you'll probably, if you really like pay attention, you'll see that K is made by a constriction at the very back of the throat or the back of the mouth.
Yeah.
And what other letter is a constriction? It's not H, I'll tell you that, because H doesn't have a constriction. It's another form of liquid, but it's kind of different. What other letter?
G.
What's that? Yeah, G, exactly. And how did the Greeks spell no?
No, I know. Yeah, I know. It's
Right?
crazy. But it bugs the shit out of me. That's what English, right? English fucks with phonetics. It's the same thing with Greek. Like, that's what I'm saying with Uranus. Like, stop saying Uranus. That's not how the Greeks pronounce it. It's Uranus, right? But yeah, totally get that.
Whenever you see a silent K at the beginning of a word, chances are it's a Greek word that used to start with G.
Yeah, true that.
Yeah,
I totally got into
this. And whenever you see a PH, that makes an F sound, it's probably a Greek word too.
Yeah.
As long as you got the keys, then it all becomes kind of beautiful in a sense. But yeah, try like being like a English as your second language learner. It's like, oh geez, like there's all sorts of different quirks about English. It's like, why is there a K? Why is there a G? And it all makes sense. It isn't nonsense. That's the one thing I don't want people to ever say, that English is like a bunch of nonsense.
See, the thing is,
it has remnants. It has remnants that tell a profound story of connection.
Yeah, but the thing is that even though I'm not sure what to say about it. Your constriction of the K and the G, the hard G. The problem is that in Greek you have kappa and you have gamma. So it doesn't make sense as to why you use a K instead of a G. Why didn't they keep it GNO?
Right. So I can explain that, and it's going to be very relatable. All right, super relatable. This is one of my favorite. This is one of my favorite topics off of phonetics. So language is going to change over time, but what are those motivations to change? Why don't people just keep speaking the way their parents spoke? Because for languages to change over time, it takes the children of parents to come up with their own slang, come up with their own twang of pronouncing words, and over time that's going to. And I bet you have already done this yourself, where you are responsible for doing exactly what's frustrating you. So, do you know that candy that has the expression "taste the rainbow"? Kind of like M&Ms, but fruit snacks instead.
Yeah, I know what you're talking about.
You want to say their name?
Skittles.
Just say like a normal person, a normal American.
Skittles.
Exactly. You used a D. It's spelled with a T, but you used a D. You said Skittles, not Skittles. Because it's a lot more effort for your tongue to say Skittles than Skittles. Skittles is easier.
It's a little bit easier to say Skittles than little.
And you spit less.
Yeah.
So we say little instead of little, right? So over time, any words that had T's, people got lazy. They just started using D's instead. And then eventually the spelling of the word itself was just like what if Skittles literally just changed their wrapper, right? They're like, fuck it. Let's just turn the T's into D's. That's the way people say it anyways.
Total Mandela, dude. That'd be awesome.
Some people would wake up and be like, oh my God, Mandela. It was T's yesterday, now it's D. Yeah, I feel it. But that's the way these changes happen. It's about the laziness of children to not want to put the effort into pronouncing the letters properly and just taking the alternative route where it's like, oh, well, it's easier to make an F than a V, it's easier to make a D than a T, it's easier to make a B than a P, or what,
Let me test you real quick. Okay, let me test you real quick.
I'm excited about what?
I gotta listen to see if I hear it. Okay, so what is 18 plus 2?
20.
Okay.
I don't even make the T sound. I don't even say 20. I say 20.
No, yeah. But I was actually thinking of a U instead of the E. So instead of 20, it's 20.
That's what I said. 20.
Right. But right. But I was more focused on the vowel rather than the last T.
Oh, and if we add 10, I'd say 30 instead of 13.
Yeah. Huh.
It's the way it happens, man. And then the spelling of the actual words. Ends up just accepting it. They're like, fine. You want to use D's instead of T's in the way you speak? Fine. We'll just spell it Skiddles. It's Skittles from now on. Fuck it.
So again, though, I appreciate that backstory, but I still don't get why the K replaced the G for knowledge.
Yeah, I don't know why they would make the transition, because there's literally no motivation whatsoever, right? Like gnosis, Gnosticism, agnostic. The word agnostic stays true, right? Agnostic, right? It says I don't know. Gnostic.
Acknowledge.
No,
Acknowledge.
But yeah, it should be acknowledge instead of acknowledge. I don't know why the spelling has changed. It could just be because the people felt like K's are an easier letter to write with pencil than a G.
That's insane.
You got me there. But it's all due to laziness. Okay, that's really what causes languages to change. It's all about laziness, or because there's some king who wants to standardize things when things start getting like out of order with like different dialects. Like, oh, Mexico, 100 years ago had 2,000 dialects, and then a president came along and said, enough of this. I'm going to invent standardized Spanish, Mexican Spanish. You know what I mean? So there's moments in history where some ruler just decides that there's too many different dialects, and he wants to invent a standardized dialect of spelling and speaking. So there's that where it's up to one man or one council, and then there's also the natural flow of change in linguistics and phonetics and spelling, where it's just based on laziness, like Skittles.
All right, so two things real quick. First thing is, I think you'll find this interesting. Do you know why, or do you know what language hydrant or hydrate is based on?
I guess Greek, just because they have the Hydra.
Yeah. Okay. But so hydrate and hydrant are all from the same root word. Do you know what the word? Do you know what the English word is that we call? Let me just say this. What do you need if you need hydration, and what comes out of a hydrant?
Water.
Okay, so that's what the word means. Okay. Except in Greek, it's spelled with a hard I've lost this term now, but it's a hard apostrophe in front of an upsilon, which is the U. Okay, so the hard apostrophe is the H sound. So it's
gotcha.
Okay, so it's hudros, but we don't spell hydrant, and we don't say you need to hydrate yourself. It's hydrate.
But right, but a Y is just a U with its tail dropped lower, right?
No,
like
no,
a lowercase y is a U with an extended tail.
Okay, that's possible, but here's my conclusion.
Okay.
The capital of the upsilon is a Y.
Wow. Okay. So yeah, that makes a lot of sense now. Yeah, I only know the I know the Greek alphabet, but I know that there's a lowercase and an uppercase version,
Right.
and I only know one of them. Right. So that's another form of corruption, or weird coding and tradition and stuff like that. Yeah. I think you're right about that. But I think that the lowercase u and the uppercase U being the symbol that we call a Y is on purpose in a sense, because it shows a tradition that's carried on to English, because the most similar symbol to U is a Y. You know what I mean? Like they're most symbolically drawn.
Actually, I disagree, because if you look at the lowercase for the gamma looks more like a Y to me than a U is, because it has that drop down curly Q. To me,
well,
I always
G. Well, think about this, right? Think about how similar a lowercase G to a lowercase y. So there you go. You just got to slice off the top of a lowercase g, and now it's a y. Same thing. It's all there, man. Like it's secrets in plain sight. Language is the most convoluted and mysterious and intricate thing that we all participate in without ever giving credit to. It's like there's nothing on Earth besides biology more complicated than language. Language is, as far as things that we learn, it is the most complicated thing that we learn. But it comes naturally just because, I don't know, it just does. Babies know how to speak by the age of 3 or whatever, It's weird like that. We don't think about it enough, though. And by the age of 10, everyone should have been taught the International Phonetic Alphabet. There is nothing more important to a person's education. And trust me, I don't know the International Phonetic Alphabet by heart or anything. Like I know the English ABCs, but if you taught, if you started teaching the International Phonetic Alphabet to a child, as long as they don't have Down syndrome or autism, linguistic genius. It's it's just how it'll go. It's a shame, and I think a purposeful, like what do you call it? Suppression. The war on intelligence, the war on wisdom in the modern world. I feel the lack of education on the phonetic alphabet should just be an example of the war on wisdom in the world. Just be good enough to push the buttons and pull the levers. And I'm getting an echo from someone.
Are you hearing yourself?
Yeah. But it seems gone now. But yeah, Greek, Latin. I mean, when it comes to the letters of the English alphabet, what's the story there? Because the Greek alphabet is very similar to English, and the Russian alphabet is very similar to English also, but the Russian alphabet today has more in common with the Greek alphabet than it does the English alphabet. And the Latin alphabet is, I guess that's what we have pretty much, just with a few additional letters. So I guess Greek came first, Russia borrowed heavily from the Greek, Latin refined the Greek, and English refined the Latin, I guess, to put it as such.
Yeah, I don't know.
But take a look at the Russian alphabet sometime. It's almost identical to the Greek alphabet, or at least there's a lot more similarities to it than English has. Even though like A and B and Y and X and M and N, like these are all shared symbols in English and Greek. But one connection Russian has to Greek is that the letter, the symbol that makes an R sound. So the symbol that we call P in English, in Greek is rho, right? So the symbol P is rho, and in Russian, they use the letter P for the R sound, and it's pretty understandable because I mean P and a capital P and a capital R are almost identical, even in English. So it's not too hard to imagine. Yeah, capital P, capital R. They don't make similar sounds, but they're similarly designed in symbolism.
Right. Yeah.
And the Russians, their symbol for P, it represents the sound R, and in Greek, the symbol P represents the sound R. So that's
Wait. So I'm trying to think through that. The symbol rho is the R in Greek. Rho
is a P.
No,
P
I know
symbol.
that. No, yeah, that's the lowercase, and the lowercase pi is for P. I don't know the uppercase. I don't know the uppercase for Greek as much as. So what's the uppercase P in Greek?
I don't know, a pi symbol, I guess. Is there like a lowercase and uppercase pi, or is it just the same?
I don't know. I don't think so.
It might just be the same symbol, just maybe with like straighter lines or something, like less curvy. Here's a fun fact about Spanish. Do you know what a cognate is?
Root?
No. Related though. A cognate is a pair of words. It's a pair of words in different languages that look the same in their symbolism, the way they're like written out with letters. They look similar. They sound very similar. And that's because they come from the same root word originally. So one thing I learned recently is that comparing English to Spanish, 70% of Spanish words are cognates to English, meaning an American, if he just wants to understand that construction is construction and just try his best to understand how that applies to so many other words. The official data is that 70% of Spanish is English cognates. And I learned all this fucking stupid conjugation and bullshit, like donde está la biblioteca, like where's the library? No, don't do that. If you want me to learn a second language, especially Spanish, first of all, teach me the phonetic alphabet, and then second of all, give me the list of every cognate, because those are going to be the easiest words for an English speaker to learn when they're literally just a different pronunciation in Spanish. Oh, construction is construcción. You know, don't tell me zapatos mean shoes. Give me the list of the 10,000 words, millions of words, or just give me the important like daily use ones that are cognates. Start with that. I mean, it's so simple, and yeah, there's a war on consciousness going on, man. This can't be just like, I was never taught about phi, like the mathematical concept of phi. I was never taught that in my fucking school. And the fact that I was never taught about phi, I was never taught what the laws of my country are. There was not a single classroom or a single teacher or class that taught me like the general laws of America. You know what I mean? Like, this is why I'm so certain there's like a war waged on wisdom and consciousness going on. Because there's simple things that should be taught. Ancient structures, the Greek Parthenon, it is literally designed with phi in every aspect of its construction. So this culture that we respect so much for their wisdom and their philosophers, you're not going to teach me what they dedicated an entire building to, like honoring, like this mathematical concept. I mean, you're never going to mention it once. You're never going to tell me that there's an international phonetic alphabet. You're never going to tell me that there's such a concept as phi that was respected among all other mathematical entities back in the day by the people we respect the most when it comes to philosophy and mathematics and democracy. It's ridiculous. And I don't know, the Greeks probably thought the Earth was flat too. On top of all that, they probably thought that as well.
Yeah, so the capital for pi is similar to it. It's two columns with a horizontal bar over the top.
Okay, just kind of a stiffer version of the lowercase.
Yeah.
Gotcha. What now that you're older, you definitely don't sound like a high school student. So now that you're out of school, what's one thing that you were thinking back, very surprised that was never mentioned to you?
Oh, wow.
How about cooking? How about raising a baby? How about how to treat a partner in a relationship well? And how to
etiquette
in so many facets.
Yeah.
I was never taught shit about cars, even though cars have been around for over 100 years. So I wasn't taught shit about how to maintain a car.
You could take shop if you wanted to. Automotive shop, wood shop. You could have taken those electives. I remember those in high school. No,
I didn't have that shit.
Yeah.
I didn't even have a wood shop, man. Like my dad, he had a bread box, as he called it. We had that during my childhood. We sold it in a garage sale sometime when I was young. But my dad, he built this like amazing bread box, as he called it, and there wasn't a single opportunity in my entire upbringing, education through public education, where I worked with wood one single time. I never held a hammer, a nail, a screw, a drill, a saw, anything.
Yeah, I think I would answer your question that two things that I've thought about in the past would be farming and astronomy.
Let's just call it gardening, right? Let's just bring it down to like the personal level, right? Like no one taught me shit about like feeding myself off of things that grow in my backyard. Sounds like probably the most important thing to give someone a skill set of. It's so simple. I wasn't taught what vegetables or what plants or whatever to plant during what time of the year and what they need. Nothing. It's absolutely nothing.
How many people think about harvesting seeds from their tomatoes and their grape and their bell peppers and growing their own shit? Like, who thinks of that? I didn't. And then when somebody
I
said it,
still don't know how to do it.
I know, but still, when somebody said this for the first time, I'm like, holy fuck, that totally makes sense. Why would you go pay for something you can grow yourself forever?
For free. Forever and for free. I mean,
you know what I mean?
Like,
crazy.
Yeah.
Oh, so you know what I saw somebody post on Facebook one time was really interesting. She posted something like, instead of throwing away your, spitting your seeds out and throwing them away in the trash can, like throw them into like a the side of the road, so that an apple tree will be there in 3 years, or a peach tree or whatever, something like that. Like, wow, that totally makes sense. Totally.
It makes total sense. I've often thought when I'm driving, in my suburban town or whatever, it's like we got these mediums between the roads, right? Like these long, 10-mile stretches of grass lanes, and I'm just like, how many trees could fit in that area? And it doesn't have to be, in the middle of the road, because you don't want like driving over whatever. But it got me thinking, like, there are so many patches of grass where it's like, how is there not a tree planted there? Like food is free. Like you plant the seed, and then it takes over from there. And there's so much area there's so many little spaces you squeeze some sort of food providing plant into to grow in this little patch of grass or whatever.
I mean, bro,
I don't see the downside.
Yeah, I'm sure you've thought of this too, but I'll just say it. There are so many properties that I drive by, and I look at them now and I think, why the hell aren't these people growing orchards? They have to spend 4 hours mowing that shit. Like, why would you do that? Why would you do that?
There's also like so many people with fences who have these giant backyards, right? They got these giant backyards with these like half-mile fences around their property.
Yeah.
And I'm like, okay, plant some trees and get some fucking goats or something. You know what I mean?
Exactly.
Like, get a couple goats.
Exactly.
They will. Yeah. They'll take care of the grass on their own. Like they'll take care of themselves. Like it's just wasted potential.
Yeah. Yep. So husbandry, gardening, astronomy.
Why is it called that? Isn't that a strange word to say? Husbandry. Like, why do you think that's the word for that?
Yeah, I don't know. I'd have to look it up. I'll look it up right now.
While you're at it, like the word wife, like I don't know a single other word that wife is related to. If you say bleed, well, there's like blood, bleed, bled, bleeding, you know what I mean? But when it comes to wife, it's like, no, wife is a standalone word. There's no other word that I even relate to it at all. Wife and husband, just really stand out words. Just out of nowhere.
It looks like it's it looks like it's going back to Old Norse husbandi, master of the house.
Anything else?
Looks like it's a combination of house and let's see, house dweller, house, and bondi, which seems to be like a dweller. I don't know. So something like that.
My phone might die soon, but I have an interesting concept to share with you. I got it from a guy named Santos Bonacci, popular flat Earth sort of icon.
Yeah, I know.
And I'm questioning what to think about him recently. But one thing he's taught me about language is you got to look out for the vowel ND, or like any rearrangement or any combination of a vowel, an N and a D, or of course you can replace the N with an M, and you can replace the D with the T. And
all right, is this working now?
Meaning of it,
Yeah, we can hear you.
is what we're.
Okay, you didn't hear anything I said before, then, right?
No.
I know. I heard.
Okay,
I think I heard everything.
WIFE stands for Y for life.
Is what? Wife
Y
for life?
for life. Y for life.
Wife for life.
Okay.
Where are you getting
And-
that from?
Yeah, I just made it up, but it sounds good, right?
Oh, yeah, it does.
And as far as seeds go, what they don't tell you too is that seeds are multiple times more fertile if they are fermented. So you know how they naturally break down their sugar. Their sugars break down
serious?
naturally. Yeah.
Are you
So like
serious?
so like when you break open a tomato, you're supposed to let it rot a little bit and get a little moldy because that's when that's when the seeds are the most fertile. So don't wash off all the slime. That's what makes it potent. The slime is the good part. Yeah, the sugar.
Yeah, so I wonder if you should just plant the whole thing. And just
Exactly.
somewhat pay, right?
What you're supposed to do is slice up the tomato and just plant the whole thing as one piece.
Right.
Just like nature. Yep. Just like nature intended.
Yeah,
Wow.
it just falls off
That's
the tree
incredible.
and rots.
Yeah.
Yeah, it's got its,
Exactly.
It's got its own.
So the
So,
whole idea of like buying seeds that are dry and unripe is it's a business.
Yeah, that's interesting.
That makes complete sense.
Totally. Yeah.
It's so simple. It's so
I wonder.
simple.
I wonder if that's why. Okay, so look. So like, if you I remember doing this one year. We chucked one of our pumpkins off the porch, and it was just the whole fucking pumpkin, because we didn't carve it up at all, and then we just left it through, like, I think through March, and it just started to rot finally at March. So I just kicked it off the side and thought, oh, I'll see what happens come fall. Well, because it had the hundreds and hundreds of seeds in it, you'd almost think you're going to have hundreds and hundreds of plants. But I only had one plant. Right? I only had this one massive.
Well, what happens is that those little sprouts, they use the same plant. So it guarantees the success of the growth because all those plants become one.
Yeah, I get you. Yeah, I thought about that because I've thought about I've seen small little saplings growing up underneath trees, and I've just thought to myself, I know what they're going to do once they get too big. They're just going to blend together into one fucking tree.
I've been listening while hanging out with my girlfriend at the same time. Seems like it went dead, but to maybe bring it back a little bit to what we were talking about, if any of those guys are still in the room, it doesn't look like it. I think the symbol for phi is exactly what Diceflow and I are talking about. Ken Wheeler talk, when it comes to the torus and the hyperboloid. The capital symbol for phi seems to be an exemplification of those two concepts, creating the one true atom. Even the way the sort of central pillar expands to the top and bottom, left and right directions. It's not just too good. I also find bull riding to be a very cool example of it, where the bull tours, or it turns and it bucks, or it bulls, it pulsates and it bucks and it goes up and down, in and out at the same time it spins. Like the universe is some sort of weird fucking poem or something. Weird how things naturally overlap and relate. Crazy way. Something to that bull and tor. Sorry, bull and tor. The bull and the Taurus. Still a mystery to me where cow fits in, but I'm sure there's something deep there too. All right, room's dead. I'm out. See you later, guys.
Testing, testing. Testing.